consists of
Okay.
which begins with the introduction part and will be followed by aim of the study, methods and phases, case study, and conclusion respectively. In the field of architecture, which represents a significant proportion of energy consumption and resource utilization, the effects of environmentally sensitive design have been observed for an extended period. Efforts to support the ecological balance through architectural design have led to the emergence of the definition of sustainable architecture. The application of sustainable architectural principles to contemporary buildings has led to an increased interest in the study and conservation of historical rural settlements that were constructed by local communities over centuries and have survived to the present day. It is believed that understanding the role of traditional settlements, which are widely accepted to be in compliance with sustainable design criteria, in fight against the climate crisis and the degree of this acceptance will positively affect the solution process of the problem. The objective of the study is to gain insight into the approaches to ecological design in historical textures, examine traditional architecture in terms of sustainability and climate adaptation, and determine the effect of traditional architectural approaches on mitigating the climate crisis problem by examining the buildings in the rural settlement selected as the study area, and the settlement itself in terms of ecological sustainability with a holistic approach. Within the scope of the study, first the questions that need to be questioned in terms of climate adaptation and sustainability have been determined. The cultural values and rural architectural heritage of Gökmense settlement, which was selected as the study area, were revealed in the light of extensive literature and on-site studies. And the rural landscape of the Gökmense was defined in terms of sustainability. On this page, we can see the questions, which were questions about the field. The results of the detailed literature research enabled the determination of the principles of sustainable architecture to be addressed in the study. This was done in accordance with the sustainable architecture principles discussed in the studies and the categories of green building evaluation systems examined within the scope of the study. Here we see the research citation list, which is examined in the scope of the study. Within the scope of the study, the principles of sustainable architecture are analyzed under two main headings, namely adaptation to the environment and climate and efficient use of energy and resources. As case study, Gökmense is a historical rural landscape area located approximately 70 kilometers from Istanbul's center. Gökmense is built on a terrace area with an average height of 60 meters above the Gökçe stream in the south. The historical rural landscape layers of Gökmense have been analyzed in three main groups, which are natural, agricultural, and built environments. Gökmense neighborhood is an organic settlement extending towards the foothills of the forest on the northern part of the highway running along the east-west axis of the land. Topographically, the settlement has a sloping terrain that increases as it moves towards the north. The building islands forming the settlement are positioned gradually towards the south in harmony with topography. Due to the sloping terrain, building entrances are generally provided from different elevation levels. The traditional built environment in the settlement was constructed using the traditional construction techniques of the region and easily accessible materials such as stone, brick, wood, and soil. Apart from the traditional buildings in the area, there are also recently built buildings with reinforced concrete structural systems. The traditional dwellings in Gökmense are basically of two different typologies, which are detached and attached ones. Traditional dwellings are predominantly two-story buildings with ground and first floors. From this page, we will be examining Gökmense in terms of climate adaptation. At settlement scale, Gökmense settlement has not been affected by stream floods over time due to its location above the stream level and has demonstrated a climate-compatible approach. As a result of the settlement in harmony with the terrain, the existing buildings do not block each other's viewpoints and geographical advantages and are perceptible within the slope. The building's forms were shaped in harmony with topography without major interventions to the lands. For Gökmasla, which has adopted an approach that does not open up agricultural areas with fertile soils for traditional settlements, it can be said that it contributes to the sustainability criteria because it has an understanding that is compatible with the natural landscape and vegetation and respects the green texture. At building scale, residential buildings generally have a rectangular compact form. Overhangs are arranged in order to benefit from the sun and provide shading. In general, in buildings with street-oriented entrances, living spaces and garden orientations are towards the south. For the settlements with rainy winter ones, eaves or gable roofs are preferred. Eaves also provide solar control. The majority of the buildings are positioned with their short sides in the wind direction to reduce the amount of surface in contact with the wind. Due to the protection and utilization of solar and wind orientations, the angle dwellings can benefit equally from the winter sun and benefit from natural ventilation due to appropriate building spacing. In the plan layout of the buildings, it can be said that it complies with sustainable architecture criteria for Gökmaslı settlements, with the use of space in sufficient number and size, determination of spaces according to thermal zoning, and open spaces aimed at natural lighting and wind control. It's observed that the occupancy rates of the north and east facades of the buildings in the settlements are higher than the south and west facades, and fewer and smaller window openings are preferred on these facades in order to reduce thermal permeability against the prevailing northeast winds, while cross ventilation is provided by the openings positioned opposite each other in the building. It is seen that wind control is provided by the natural landscape elements used around the building. In Gökmaslı, there is no consumption of fossil fuels such as oil and natural gas in the settlements, and it's observed that wood obtained from the surrounding forest under state control is used for heating purposes. Today, traditional buildings in Gökmaslı settlements are integrated with active energy systems that utilize the sun as a renewable energy source. Solar collectors placed on the roofs of the buildings are used for water heating, contributing to meet the domestic hot water needs and reducing energy consumption for heating purposes. In Gökmaslı, there is no system for recycling rainwater or grey water in the settlements. While no roof gutters were found in the original buildings, it was observed that the water accumulated in the gutters added in later periods was discharged from the building through pipes, and in some examples, this water was collected and reused with portable containers. In conclusion, when the results obtained for the traditional settlements of Gökmaslı, it can be stated that positive results are observed in 11 out of 12 criteria under the headings of adaptation to the environment and climate and effective use of energy and resources. But it can be stated that sufficient positive evaluation cannot be made for the criterion of effective use of water. Considering the topographical features and climate conditions, it can be said that traditional buildings built in line with the needs of the users fulfill most of the principles of sustainable architecture. However, in order to ensure the full sustainability of rural settlements, they need to be supported by various improvements in social, economic, and cultural contexts. For the last two pages, we can see the final evaluation for local sustainability of the Gökmaslı case. And this was the end of my presentation. Thank you all for listening to me.
Thank you so much, Senem. Then we'll move to the other paper, evaluating sustainable approaches for enhancing building resilience in response to climate change, case study, Tehran City, for Dr. Paraya and Dr. Horakshnia. No, there is no. There is no link for the. Dr. Paraya is here. Is Dr. Paraya here? Okay, so there is no link for the presentation. So we'll move to the other one, an assessment of the effects of manual energy and material haulage on the initial embodied environment impact of residential buildings by Emmanuel Eudomia and Remgius Mugara and Oshia Ikpa. Sorry for the pronunciation. I don't know whether it's right or not, but we can share now the link.
Mogara and Ochia Ikpa. Our paper topic is an assessment of the effect of manual energy and material haulage on the initial embodied environmental impact of residential buildings. By way of introduction, the imperatives of the need to reduce embodied energy and embodied carbon emission have remained on the increase and gaining attention also from key players in the building and construction industry. From existing studies, building material extraction and haulage consume a lot of energy with substantial carbon emission, about 33% of the world energy consumption and approximately 40% of direct and indirect carbon emission are traceable to buildings and construction activities. Despite their significance, they are still substantially unexploited. Initial embodied energy and emission are components of the total energy and emission of a building. When we talk about initial embodied energy, we refer to the energy for extraction, transportation, manufacturing, and construction. From the existing studies, we found that there are local and international existing studies on life cycle energy and emission of residential buildings. However, the operational stage within the life cycle dominated the documented and published life cycle energy reports, with the assumption that the embodied energy and emission at that phase is inconsequential. A good example is the Sri Lanka study, which reported a dominance of cradle-to-gate material embodied energy, reporting 61.12% and 17.74% respectively. A notable study by Fatah et al. Also reported that labor is a major component in the construction industry, especially in developing countries. Manual labor energy is often not considered, and the portion of energy linked to material haulage is generally argued, as reported by Desert in 2012. Atishbe et al. 2019 also reported that there is paucity of knowledge of labor energy outlook as an impediment to the effective adoption of ecologically friendly construction methods within the Nigerian construction industry. This underscores the need for more studies to identify the contributions of local peculiarities, such as manual labor, to the environmental body, especially in developing countries with high manual energy intensity. Statement of problem and purpose of study is, as earlier stated, embodied and operational phase make up the life cycle energy emission of residential buildings. The building process in the Nigerian housing sector is manual energy or manual labor intensive. Yet, the available assessment framework hardly ever include manual energy and the peculiarities of haulage processes in the study area. Therefore, the study aims to appraise the environmental impact of materials transportation and the construction processes with regard to manual labor and machine in the Nigerian context, with the view of identifying ways of reducing environmental burden, especially in the embodied phase. To achieve this, we have two key objectives. Objective one is to assess the environmental impact of building materials and material haulage. Objective two is to determine the percentage contribution of the construction processes, and that is manual and machine energy. Material and method. The study is quantitative in approach and adopted a survey research design using multiple case studies and also integrated the International Energy Emission Protocol. The study area is Abakaliki, Nigeria, southeastern Nigeria. Moreover, the study adopted the process-based energy and carbon assessment framework to analyze a purposive selected apartment buildings coded as T1, T2, and T3, with each code representing a different architectural design having the same location. Data were obtained primarily from documentation, identification, and computation areas and energy flow of the case study residential buildings, which were deduced primarily from the floor plans and specifications sheets provided by the government development agencies. The results from the study shows that cradle to gate material embodied energy was dominated by the substructure by 31%, whilst the substructure also dominated the cradle to gate material embodied emission by 47%. The study found that diesel consumption for concrete mixers, bulldozers, and earth-moving equipment constituted more than half of the site construction energy and emission for the reference building T1, T2, and T3. The study also found that the site construction energy for the reference building, the energy from the machine was 93%, while manual labor was 7% of the site construction energy. Transportation energy stroke emission were also computed for T1, T2, and T3, and were found to be the values are presented in the slide. The discussion will be in accordance with the objective that has already been mentioned. Objective one, the environmental impact of the building materials and material haulage. The building material created to get embodied energy and carbon emission of the case study buildings accounted for 83.2% and 91.5% of the initial embodied environmental impact, with an average energy intensity of 2,583.57 megajoules per square meter and 351.02 kilograms of carbon dioxide emission per square meter, respectively. Regarding transportation energy and emission, the transportation energy and emission accounted for an average of 11.65% and 6.95%, respectively. The values obtained in the study are significantly high when compared with other existing local and international studies. For example, Utama and Etat reported 1.13%, while Ramsey reported 3.8%. When you compare the values, you find that the value obtained from the study is comparatively high. Objective two, the percentage contribution of the construction process, that's manual and machine. The construction energy and carbon emission contributed 3.9% and 1.52% respectively. Notably, manual labor accounted for 7% of the total site construction energy, while the average manual labor energy intensity for the study area was 9.5 megajoules per square meter. In conclusion, the comparatively high haulage energy intensity observed in the study area, which is characterized by high surface transportation mode and the usage of old diesel power trucks, is indicative of the effects of building material haulage on the embodied energy of residential buildings in the studied area. Therefore, an efficient building material transportation mode could also be a solution for the reduction of the embodied impact in the housing sector and the construction industry. The study therefore also suggests an age restriction of less than 5 years for imported trucks and the introduction of trucks with hybrid energy. Lastly, the value obtained for manual energy is very significant, as we have observed. This underscores the imperative of integrating manual labor energy in the environmental profiling or in the life cycle assessment, energy assessment of residential building in developing countries. Thank you for listening.
Thank you so much. So now we have finished the 4 researches. If anyone wants to ask any question for the authors, let me start with a question for Senim. Are you here, Senim?
Yes, I'm here.
Hello, Senim.
Hello.
Thank you for your effort in the research. It's very nice.
Thank you.
I just want to ask or to clarify, maybe it's not clear for me. You have made different cases for the residential unit that you were testing. Is that right?
I studied in one settlement, but in different buildings.
In different buildings?
Yes.
Okay. And then at the end, it was not clear which one gave you the best or the ideal solution or the ideal design.
Yes, I made the general evaluation of the settlement, not a specific case. I evaluated all of the traditional houses in the settlements and make a general approach to the settlements in terms of the sustainability conditions.
So you didn't give a priority to something, or you have generalized your choice. Is that right?
Yes, yes. I made us a general assessment of a settlement. Yes.
Okay, okay. Is anyone want to ask anything? So let me move to the other paper, which is atrium design in hot climate and dry climates, understanding the influence of architectural form variation on indoor thermal conditions, for Khalida Boussachi and Professor Nuruddin Zumuri and Dr. Shafiq Mahaya.
Hello everyone, this is Khalida Boussachi, a PhD student at the University of Mohammed Haidar Biskra in Algeria, Laboratory of Architecture and Environment Design, supervised by Professor Mr. Nuruddin Zumuri and Dr. Mahaya Shafiqa. This is our topic for today. It's about atrium design in hot and dry climates, understanding the influence of architectural form variation on indoor thermal conditions. This research was born from a general reflection that the basic requirement for a building is to provide shelter from the external environment. Although buildings are not just structures, they house occupants, who must be comfortable and healthy in their environments. However, the office worker in modern society spends less than an hour a day outside. As a result, the comfort of buildings' occupants is why the structure was originally designed. With this in mind, among the architectural solution adopted in modern buildings was the integration of the atrium. The atrium is becoming more relevant in desert Algerian regions as a key architectural and functional element in the urban landscape. We are observing an increasing integration of centralized atriums in public buildings. Its emergence often represents a transformation or replacement of the traditional courtyard that characterizes these regions. Its introduction into buildings doesn't come just from the interest of incorporating an aesthetic element into the buildings. It provides better protection against external elements such as excessive heat, wind, or dust, and the need for an attractive interior environment receiving daylight, solar energy, and air. However, designers often pay attention to aesthetic and design while ignoring user comfort. The study investigates the influence of architectural aspects of the indoor thermal behavior of an existing centralized and inclusive atrium in the hot and dry climate of Lagoa City in southern Algeria. By testing two variables, namely height, which is presented by the index SAR, and glassed area ratio. The building atrium selected presents a centralized atrium rectangular in shape, 70 by 8 meters and 12 meters in height, naturally lighted only from the roof by a huge glass roof inclined at 10 degrees toward the south, and which covers the roof of the atrium at 100% without any shading devices or openings. This simulation and the analysis were carried out using the TAS software for dynamic thermal simulation. The simulation covers summer period and a representative July day was taken. The first simulation group, the SAR, is defined as the atrium height divided by the north-south width of the atrium. On this case, the simulation is carried out on 3 SARs. So here we have 3 height chosen in which way we have obtained small SAR, which the height is less than width, medium SAR, height is greater than width and less than 2 widths. This is the basic case, and the large SAR where the height greater than 2 width. For the second group, glassed area ratio, it includes 3 ratios, 100% for the basic case, and 75% and 50% are carried out. So for the 3 configurations tested in the first group, each high SAR is simulated with the 3 ratios. Some results: the atrium is simulated for one chosen time of the day at 3 p.m., the most critical occupancy and solar penetration hour of the day. The analysis of thermal gradients of temperatures in relation to height between the 3 cases of SAR shows us that the degree of heating which is due to penetrating solar radiation varies according to the different SARs of the atrium. So it shows that an atrium with a small SAR, the thermal stratification is done linearly, so is overheated more substantially than a higher atrium with large SAR and medium one. However, we observe more pronounced stratification in the medium and large SAR, where the intense solar radiation at the upper level of the large SAR has results in higher stratification. For the second group, the glassed area ratio variable, the vertical distribution temperatures are specifically presented with different ratios. It shows that the thermal gradients for the different glassed area ratios respond at identical rates with each of the configuration of SAR variable, which means that the reduced of the area glassed ratio did not always affect the behavior of the atrium in terms of thermal certification. The analysis of the different temperatures obtained at the floor and roof levels seem interesting for different glassed area ratios tested according to the 3 SAR. It shows that for the small SAR, reducing the ratio has a significant effect on reducing indoor temperatures. For the medium SAR, we first note that reducing ratios has relatively reduced the indoor temperatures compared to the small SAR. The large SAR reducing ratio for this case has less impact on the reducing indoor temperatures. However, reducing ratio is more influential at the upper level near to the roof compared with the ground roof level. So this can be justified by the fact that since the small SAR receives more of solar radiation and the sunspot is more extensive in volume, reducing the glad area ratio so can have a greater impact on reducing indoor temperatures. In addition, the large and medium SAR, the atrium being higher, it becomes self-shaded by receiving less amounts of solar energy. So, reducing the ratio will not have significant effects for a large SAR. However, reducing the ratio is more influential at the very high level of the roof, since the latter receives more quantity of solar energy. Furthermore, changing in glassed area ratio had little effect on the thermal environments for the case of higher atrium with large SAR. So it's not true that changing glassed area ratio can have always effect on atrium thermal environments. In conclusion, it's proven that architectural aspects is an important factor to consider in atrium design in hot and dry climates. It influences both conditions of indoor thermal environments and thermal certification obtained at the atrium, in such a way that the decrease or increase in the glassed area ratio remains influenced by the height or the SAR of the atrium. It demonstrated that for the hot and dry climates, the regions, the atrium at medium SAR is favorable with decreasing in its glassed area ratio. However, atrium at large SAR is more favorable, and the atrium at small SAR remains the most unfavorable, even by reducing its glassed area ratio. Thank you for your attention.
Thank you so much, Khalida. And now we can move to the next research. It's about an overview of the research on passive solar strategies for Joy Nanlop and Associate Professor Parasto Provahidi.
Yeah, I'm here.
You're
I'm here. Good.
Okay.
I'm here.
Now we are going to share your presentation.
Hello. I am Joy Nanlop, a PhD candidate of Cyprus International University. I'm here to talk about our research article, an overview of the effects of passive solar strategies and thermal comfort. This research basically analyzed 547 publications to identify the knowledge gaps and research trends in the field of passive solar. Buildings are major consumers of energy, and they are contributing factors to the emissions of carbon dioxide in the environment. Passive solar strategy, it's a renewable source of energy, and the research tried to cover a period of 40 years, which was between articles published between 1982 to 1982 to 2022, and from that, the capacity of passive solar strategies to offer long-term and affordable solutions for indoor thermal comfort has driven us to this research. Passive solar techniques for energy efficient and eco-friendly buildings, and how it is easy for most climates to access solar radiation and harness it into achieving thermal comfort of our building. There are various passive solar strategies for heating and cooling purposes, and they actually work for both scenarios. So for passive solar cooling, we look at the thermal mass, the convective cooling, the shading, the ventilation. While for passive heating, we're talking about direct gain, we're talking about indirect gain, we're talking about thermal mass and insulation, and we're talking about shading as well. For the objective of this research, we just tried to gain the research gap in the field of passive solar, especially as it relates to passive comfort. And for the purpose of this research, we had a keyword search, and on the Web of Science data page, from there we tried to specify our keywords and search with refined search parameters. We excluded, we refined articles, and then we had a final data of about 547. We came to 1,400 and 1,406, and then from there we went to have detailed cleaning, and we arrived at 547 articles, which we finally downloaded and used to run our analysis on viewer and our studio. For the thematic analysis, we extracted the Excel file for the data, we cleaned it, and then we arrived at about 500. We just cleaned the 547, but now after further cleaning, we had a total of 500 articles, and we ran it, uploaded it on MaxQDA, and ran the analysis for our thematic. So we tried to see plans, we tried to see themes, we tried to see emerging areas that have predominant researches, like we can see over here and over here, while these ones are still like virtually untapped. So for the reference publications, it had an increasing trend of publications up until 2015. Then from a noticeable decline can be seen from around 2018 and even lower in 2022. And it got us questioning, why is it that there's a sudden decline in particular research? And for bibliometric analysis, it just helps us to measure metrics, counts, and observe frequencies in this particular field of research. And we try to check direct citation, keywords occurrences, what keywords are common in this particular field, and then authors that have collaborated, affiliations that have collaborated, to see what the dominant of the researches on this particular field is. And for our primary data, like I said earlier on, we had complete data from Web of Science, and publication trends were there until 2018 thereabout, and then there's a sudden decline. So the aim is to see our solutions, trends, and gaps in previously published articles. So it gives us a guide into where we would want to dive into for further studies. So this particular exercise, the bibliometric part of it, it just helps us to have a summary of things that's where the research can go to. And for the results, we had some universities which had higher publications. We had most of the publications coming from specific journals, and we also have this showing the connection between the keywords and author, university, and then the author location. So it just gives us a good. This particular image shows us that there's a strong relationship between various titles associated with the study and the author affiliations and author countries, which it's basically a summary of details. So we use co-citation analysis to reveal the relationship among authors. Key author analysis provides insights, and it helped us to see where most researches have been centered on, where those others that need more direct citation. The circumference of the circle indicates how many citations. So the circumference of the circles indicates how many citations an author has accumulated, and as close, those that are positioned close to one another in this visualization have a stronger relationship than those farther apart, like it's shown here. This particular visualization is key because for keywords are related to core content of a publication, and analysis of keywords can show us crucial and critical results of studies related to passive solar strategies. This one gives us an overview of the keywords, and I think it had a total of about maybe 2,000 or slightly above 2,000, with a minimum of 10 documents per author that meet this threshold. And we have like thermal comfort and like performance coming up, and we have things like passive cooling, really looking far apart. For the thematic part, we had an initial code where 7 codes were applied and focusing on thermal comfort research. However, we added an extra 6, which like almost nothing, and we specialized it on that. In summary, the analysis reveals a varying attention to different subtopics within building energy efficiency, while thermal comfort, cooling, and simulations are extensively studied. Passive solar solution required investigation. So for energy consumption and impact, we saw that despite increased research publication, energy consumption remains high, posing a question about the effectiveness of current strategies. So for us to address priorities, should papers appear accepted based on understanding energy saving solutions rather than just applying complex? Despite benefits, there's a lack of research in passive solar design, indicating the need for further investigation. So it's a call to all of us to go into more research for passive solar. We're trying to save the world from energy carbon emissions, and we're trying to energy and reduce our level of dependency on fossil fuel. However, for future directions, research needed for passive solar strategies to reduce emissions, despite research energy consumption remains unchanged based on figures we encountered, lack of comprehensive research on passive solar solutions for further climate changes. The goal is to shift focus from research towards passive solar methods to positive impact. So we want to encourage us to research into positive areas that would have good results that can easily be applied and would see a considerable decline in the numbers on energy consumption. Future research should include accessible articles for builders to promote efficiency. Thank you so much.
Thank you, Joy, and we'll postpone the questions to the end of this session, okay, until we finish all the papers. So now we'll move to the other paper. It's about the impact of facade setbacks on energy demand by Associate Professor Bukarta Sufyan, Bumara Muhammad, and Associate Professor Huraksh Ahmad Nia. Is Associate Bukarta here?
Yes, I'm here.
Okay. I'm sharing now the link.
Yeah.
We are very happy to present to you our work entitled The Impact of Facade Setbacks on Energy Demand. This work is done by Dr. Bukarta Sufyan, Mr. Bumar Mehdi, and from the University of Blida, Institute of Architecture and Urban Planning, and Dr. Urak Ahmed Nia from the University of Alanya University, Turkey. We would like to begin our work with urban expansion. Urban expansion generates more housing construction, more consumption of energy, and more GHG emissions. And this cycle will create more and more risks linked to the climate change, like rising temperatures, rising the level of sea, and several other risks. We would like here also to take a look to our housing stock regarding the energy demand, and here we could see that there is a huge correlation between the heating degree days fixed to 20 degrees and the consumption of gas, which is more than 80%. And in the other side, we can see also that the electricity consumption is highly linked to the cooling degree days fixed to 27 degrees, 74% of correlation. This means that the energy consumption of residential buildings in Algeria is highly sensitive to climate variations, and that the building stock is poorly adapted to the climate. Now we can here ask our question. The architectural design partly explains this growing energy demand and fight the facade setbacks. which are really a recurrent practice in Algerian architecture and are widespread throughout the country, regardless of the climate differences, as you can see here from this figure. And here we can say that facade setback has been already studied in several papers, but has been approached by socio-psychological approach, like it has been done by Shujai and al. Also by the work of Q. Kang to study the wind movement, or green facade with Perez et al., air quality like the work of Da Silva et al., and now the energy demand. This is our purpose in this communication. The aim of the paper is to explore the impact of facade setbacks on the energy demand of a residential building in the Algerian construction system context. The method is based mainly on dynamic thermal simulation, which consider first of all a characterization of the design of experiment, which is a generating housing model, and the weather conditions and the setbacks parameters. After that, we run several simulations under Design Builder, which works with Energy Plus engine, to get the air conditioning requirement, the heating requirement, and the total energy demand for this for our building of study. And then we proceed to do the management of our output in Excel, and the sensitivity analysis is based on a comparison between the three situations, and this method allowed us to get the result about how important is the setback regarding the energy demand. So first of all, we have considered the case study of Algiers, and based on climate consultant, we can see here that the psychometric diagram shows that Algiers climate is 13.3% thermally comfortable per year, and that the passive solar gains could further improve comfort up to 12.1%, while shading strategy contribute up to 14.2%. So through passive design strategies mentioned here, the hydrothermal comfort can be improved by up to 40% per year. And the sample chosen are an assembly of two frames of 6 times 4.5 meter square. Each frame is glazed with surface area of 12.5% of the surface area of the frame. The external walls are double walled with an air gap. All the characteristics are identical for the three cases. Our approach is to set all the other parameters apart from the facade setback, so that the results can be read more accurately and interpreted more precisely at a later date. So the residential building here is presented in these three cases. The first one without setback, the second one with setback of 1 meter of depth, and third one is the case with setback with 3 meters of depth. So here we have also considered the orientation of our design of experiment with north orientation, east and west orientation, and the west and the south one, and we have obtained for all these orientations and for all these cases the heating and the cooling energy demand. So the results here and are discussed. The first of all, that for cooling energy demand, we can see here that baseline is always demanding less energy demand than for the cases which consider the setback with a depth of 1 meter and 3 meter. And we can also see that an augmentation in crescendo going from an orientation from the north to the west orientation, which means that has an important role with the setback depth. And we can see that the baseline, which without any setback, consider only 50 kilowatt hour, and with 3 meter of depth with the west orientation, the conception is more than 3 times important than the north one. And exactly the same results is observed with the heating energy demand. The baseline is without setback is always the best case, and here also we can see that the best case for the heating is the orientation to the south, which could be explained by the gain of solar heating. So and here we can see also that the heating is more and more important than cooling energy demand. But the impact of the setback vary from more than 30% in the for the north orientation, and the most important variation is observed with the south orientation, when with an impact that could surpass 80% for the 1 meter depth, and quite 100% with 3 meter of depth. And also we can see that for the impact of the reversed orientation of the setbacks on cooling and heating energy demand, we can observe two things. For the setback with 1 meter of depth, the result of the two groups are relatively similar, and the difference is lesser than 1%. And in the second situation, with a setback of 3 meter of depth, we can see that the group 1 performed better than the mirror group, whatever the orientation. The difference between the two groups varies according to the orientation. In the conclusion, we can state that the setback or the facade setback has an impact on the energy demand of residential building, which could be marginal if the depth of the setback is less than 1 meter, and it could be very important influence on the energy demand for cooling and heating if the depth of the setback is 3 meters and higher. The orientation also has a huge impact on energy demand with buildings with large setbacks in the context of the Algerian constructive system. Thank you for your attention.
Thank you so much, Professor Dr. Boucarta. And now we are going to move to the last paper. Then we'll have some time for the discussion. Now we are going to present the paper concerning with examining environmental exposure to extreme heat, an HVI-based assessment of Lusaka city for engineer Jadidia Shibanja.
Hello, I'm Jadidia Chwinga, and I'll be presenting the findings of the research where we carried out an HVI-based assessment of Lusaka city in order to examine environmental exposure to extreme heat. I carried out this research with Dr. Nyimbili, Mr. Sakala, Dr. Banda, and Professors Manaumu and Professor Tuara. Climate change is one of the most pressing challenges of our time, with urban areas particularly vulnerable to its effects, especially those still experiencing rapid expansion. With global temperatures increasing, extreme heat events are becoming more frequent and intense worldwide, and this poses a significant risk to human health infrastructure, as well as ecosystems. Today, we will explore how zones in Lusaka City, which is the capital city of Zambia, and the rapidly expanding urban center in Africa, are impacted by climate change in the context of extreme heat vulnerability. This research aimed to investigate the heat vulnerability across different neighborhoods in Lusaka, as well as provide evidence-based information that can help mitigate this heat vulnerability by various stakeholders such as policymakers as well as urban planners. So the main goal for this was to bridge the knowledge gap that existed with regards to how vulnerable different neighborhoods are, as well as the mitigation efforts that can be put in place with the whole aim of effectively combating climate change in the city. So in order to carry out this heat vulnerability assessment, we use Landsat-8 satellite imagery from the summer of 2022, and from it we derived various information with regards to the indicators used, such as barren land, the amount of vegetation cover, the land surface temperatures in each particular neighborhood after we overlaid this information with the neighborhood boundaries. And after doing that, we're able to obtain the relative vulnerabilities of each particular neighborhood with respect to each indicator. And thereafter, that information was aggregated in order to obtain the overall heat vulnerability index. So the results from the methodology in the previous slide are actually HPI marks with respect to each indicator. So from the satellite imagery above, we actually see that areas such as Olympia and Avondale with high proportions of vegetation have very low heat exposure vulnerability with regard to this indicator due to the cooling effects of vegetation. In contrast, neighborhoods that are rather dense, informal or squatter settlements like this is shown here have very high exposure due to very low proportions of vegetation. These images basically further highlight the contrast between the characteristics of the plant affluent neighborhoods shown in this image above compared to informal settlements shown in this image below. When you look at bare land as an indicator, we actually see that areas with low proportions of exposed bare land due to high vegetation, but mostly this is due to very high impervious surface cover, such as this area highlighted here, which is a central business district of the city. So these areas generally have low exposure. In contrast, zones within the city with high bare land are generally those that are built up areas such as Leopards Hill here, or areas such as farmlands, like Lilai shown in this image below. So these farmlands are generally dry, or they tend to be dry during the summer times of the year, hence the exposed bare land. Now, when we look at impervious surfaces as an indicator, we see that areas with high proportions of vegetation and exposed bare land, such as Twin Palm and State Lodge, are shown in this image here. For Twin Palm, they have very low vulnerability. But in the central business district, where we have excessive concrete and bituminous pavement, as well as very dense buildings, we have very high vulnerability in the context of this indicator. Here we see another image highlighting the proportions of impervious surfaces in the city's central business district compared to other land cover such as vegetation as well as exposed barren land. So with land surface temperatures indicator, we actually see that neighborhoods with very high vegetation tend to have very little bare land, as well as very low impervious surface cover, and this generally lowers the land surface temperatures in these areas. However, high vulnerability with respect to land surface temperature generally runs across several types of land cover, ranging from neighborhoods with sparse impervious surfaces but high proportions of bare land, such as shown in this image of Livala. In addition, neighborhoods with dense impervious surfaces, such as the central business district, as well as squatter settlements, tend to have very high exposure with respect to this indicator. Okay, so after obtaining the heat vulnerability indices with respect to each indicator, this information was aggregated to come up with an overall heat vulnerability index map with HVI scores ranging from 8 to 17. These scores were later classified to come up with our final exposure map. So analysis of our results actually found that more than half of the city, which is about 69 or 70%, is actually at very high risk in terms of extreme heat exposure. And actually very less than 5% have very low exposure, which is quite alarming for the city. So if we take a look at the HVI maps with respect to each indicator, as well as the overall map, we actually see that there's a lot of spatial variability in the city of Lusaka due to the varying land cover characteristics in each neighborhood. This actually necessitates the need for this research so that targeted measures can be put in place. So we went on to identify potential mitigation strategies that can be put in place. The first one was in the context of urban planning, that addressing land use practices and promoting green infrastructure can help mitigate heat-related risks. And therefore, urban design has an effect in reducing environmental exposure. Still looking at mitigating strategies under urban planning, below is a picture showing the current trends in various Lusaka neighborhoods, where we actually see either excessive pavements or exposed bare land with very little regard for the amount of vegetation in these particular areas. Therefore, in the short term, we actually recommend that the various stakeholders, such as the city councils, should actually seek to enforce that strategies such as green roofs, as well as permeable pavements, and other green initiatives actually enforced in the city to ensure that this heat vulnerability is reduced. Another mitigation strategy that we looked at was actually public health. And basically, this illustration at the bottom tries to highlight the blanketing or the cascading effect of urban planning in the context that if we design urban areas that are resilient, we actually have the potential to curb the negative side effects that arise due to poor urban planning. This illustration highlights the positive cascading effect of mitigating strategies. So basically, this means that if we design for sustainable land use practices and climate resilient urban areas, we actually greatly lessen the burden of extreme heat on the health of the population as well as on the health sector. This will in turn ensure that the city is highly adaptive to the negative effects of climate change. Therefore, investments in sustainable land use practices and initiatives tailored to the unique environmental characteristics of each neighborhood will ensure that there's reduced extreme heat vulnerability. It is therefore of great importance that localized investigations are carried out to account for the spatial variations in our cities. By employing strategies such as promoting the preservation of vegetation, we ensure that we achieve our 3rd and 11th sustainable goals, which are to ensure good health or the well-being of both humans and animal populations, as well as to develop sustainable cities and communities that are resilient to climate change, respectively. In terms of the future directions of this research, further research in Lusaka should consider the socio-economic as well as the demographic factors that affect heat vulnerability. This will ensure that a more comprehensive vulnerability assessment is carried out for the city of Lusaka and more effective mitigating strategies and methods are employed. Thank you very much for listening.
Thank you so much for all the presenters and participants. And now it's time for discussion for the previous 4 papers. So I have the co-chair, Dr. Bukarta. Are you here?
Yes, I'm here.
Okay, so now also it's the floor for you to ask if you have any questions for the presenters.
Yes, I would like, first of all, to thank all the presenters for their clear presentations. And I have a question for Bousipsi, I think, who worked on the atrium impact on energy demand.
Yes.
And yeah.
Yes.
Yeah, I would
I
like
have-
to ask a
Okay.
question about difference between the atrium and the courtyard impact in the case of the city of Biskra, I think. So she worked only on the atrium cases.
Yes.
Yes. And I think that in Biskra, courtyard is very spread as a design element in architectural context. So I don't know if she could give us a difference between the behavior of the atrium in regard of the atrium regarding the energy demand.
Okay. So Khalida.
Hello.
Hello, Khalida.
Hello. Thank you for your presentation. Thank you, Mr. Sufyan Bukarta, for your relevant question. Actually, I'm working on the atrium as a
Yes.
space. The atrium, we can see the difference between the atrium and courtyard. The atrium is covered by a huge glassing roof,
Yes.
while
Yes.
the courtyard is an open space. So
Yes.
in my case, I studied the enclosed atrium without any opening or shading devices.
You don't know if who is best working, the atrium or the courtyard when it's open? Open.
Really, in the hot and dry climates.
Yes, like Biskra, I think that you have worked in Biskra. No?
Oh, in Laghwat, but Biskra, yes.
Yeah, it's the
But
same. Arid climate zone.
Yes, they're the same region, dry climates with dry climates. There is some research,
Differences.
scientific research, and when they study the difference between the courtyard and atrium. So in the behavior, in energy or in thermal environments. So yes, but I'm focused on atrium because it's a transitions. Nowadays, the courtyard it became you can
Traditional.
say traditional. Yes, traditional. But there is a transition, a replacement of the courtyard to atrium, because
Yes.
atrium is like a shelter against the external environments.
Exactly, but we have to know because in Biskra or in Laghwat, it's dry.
Yes.
I think that who is working best, I think that the courtyard will work best because it's open all the time and it manage well the wind circulation.
Yes, but
I think.
we have the problem of the dust, the
Yes,
sandstone.
yes, yes.
Because the traditional courtyard, it became atrium and covered by a huge glass. So we need to have to focus on research how evaluate the atrium, or how to this atrium became a positive space in our architecture. Well, there is I can't say if atrium work better than Courtyard because it demand research
Yes.
and study to say who is the best.
In a dry climate?
Pardon?
In a dry climate like Lawat?
Yes, in dry climate. Yes, no, there is no study.
There is no study. Yeah.
No, there is no study. And there is no study. The atrium, this is the first study in Algeria. In all Algeria, this is the first study of atrium in dry climate region.
In dry climate, yes. There is the work of Professor Boucher from the University of Algeria.
Energy conception.
Yes.
I'm in the beginning, so I can't say anything about that.
I think that you will do better to introduce the case of the Courtyard to your cases study, to handle this
exactly,
question.
Yes, exactly. Because the atrium is a transition, is a replacement.
Yes.
We must. Yes. I understand. Thank you.
And for your cases also, you have considered only the simple glazing for the three cases.
Yes, just the simple.
What do you think?
It's a case study. But the three cases is just modulation. It's just modulation. Yes.
Okay. In the future, I think that you will do some in situ measurement to be able to propose some other solutions.
I did. Just I didn't show it in present. Yes.
Okay. Thank you, Khalida, for your
welcome, Sfian Bukarta. Welcome. Thank you.
Thank you.
Okay. Any other questions?
Yeah, I do have a question. I have a question.
Yes, let's go. Joy, you want to ask something?
Yeah.
Okay.
Sorry. I want to ask a question. I want to ask a question to the presenter that worked on the facades.
Mm-hmm.
Yeah, I just want to clarify something. What optimization procedure did they follow to get their final results, please?
The question is for me, I think.
Yes.
For the setback.
Yes, the setbacks.
Yes. I did not understand well your question. What is the?
Okay, my question is: you run your simulations on Energy Plus, right? Yeah.
Design Builder, yes.
Yeah. So I just wanted. Okay, is it Design Builder or Energy Plus?
Design Builder with the Energy Plus engine.
Okay, with the Energy Plus function in Design Builder.
Yeah, exactly.
Yes, I wanted to clarify your optimization. Did you optimize your results?
No, I did not optimize my results. I just I have just done a comparison between a baseline that it doesn't consider the setback in the design and the depth of the setback. Yeah.
Okay, so
because
for your validation, you kind of just did a comparative analysis for your validation, right?
Exactly, yes. But for the case of the construction system, the Algerian construction system, I think that if we transpose our results to the European case, I think that it would not work because the insulation is higher than in Algeria. So we could get other results because in Algeria, the insulation of the external wall is the resistance, the thermal resistance is 0.60. Yes, it's 0.60, and in Europe is fixed to 2 or plus or higher. So the difference between the Algerian case and other countries' construction system, it has to be considered before running simulations. So here it's just a simple comparison between design that considers setback and other. Yeah.
That's fine. Thank you very much. Thank you.
Welcome.
Okay. Joy, I have one last question for you because we are running out of time.
Is it for me or my professor?
Yeah.
My professor is also on the call, so would it be to me or to my professor?
For your paper.
Yeah, because I said we did it together, so my professor is also on the call. So if I can't answer, she would answer.
Okay,
so
no problem, no problem. You have mentioned some terminologies or some terms in a diagram that we should study before we make passive solar design. Is that right?
Okay. What we tried.
But the problem is you didn't exactly mention which more terms we should study before we make our design. Do they have all the same balance, or there are some things that are have more balance than others?
Okay, when you check the images we have for the systematic literature review, you'll see that some terms, no, let's even go about the thematic review now. Some terms that relate to passive solar have actually not been properly explored based on the analysis we ran. So it's like I just quickly want to have it open so that I'm able to point, because I can't go back directly, but I just want to open it so that I would be telling you as I'm doing that. But what we just tried to show in that particular research is there are lots of untapped, let me call it untapped research in passive solar, and based on, mostly when you do thematic analysis, it goes on your search words. And when you check, okay, I'm not there. If you check like words like cooling, passive cooling, solar, all those ones, you can see that the diagrams there are quite tiny. That's to show that there's very little of that. But when you see like thermal comfort has a lot of publications. Energy performance has lots, thermal performance has lots, but natural orientation, we still have a lot of work that can be done there. Then when you go to now the thematic one, you'll see that like passive solar strategies, we just have about 6 researches on that entirely out of the 500 we went through. Then for passive solar, we just have 12. But when you see simulation, what's like simulation has like 230.
Oh, yes.
So, so the gap is actually quite wide. But cooling, there's 200, heating, but passive solar strategies has actually a lot to be done.
Okay, thank you so much, Joy. Thank you.
Thank you very much.
So, any other questions?
Yeah.
Okay. Dr. Bukarta, you have a question?
No, it was all the presentations were very clear and
to the point.
To the point, yes. Yes. That's it.
Okay. So I'd like to thank all the presenters for their very good presentations, very clear and to the point presentations. And we hope that we all have the approach of sustainable architecture and sustainable buildings in the future. So it's time now for me to leave the session and go to the the other session with Dr. Fondaten.
Yes.
Dr. Fonda, yes, Dr. Fonda, hello. The voice.
Sorry, I didn't turn on my microphone. Hello, it's me. I'm Funda. I'm from Turkey, Gebze Technical University. I'm a faculty lecturer over there. And next session, I will be moderating.
Okay.
Yeah, that's
So,
all.
Dr. Funda, nice to meet you.
Nice to meet you.
I'll give you to be the host now so that you can run the presentations.
All
Okay.
right.
And I'm with you instead of Dr. Salar. If you have any technical problem until he comes back. Okay.
Okay.
Now you are the host.
Okay, and now I'm the host, and if I have any technical problem, should I ask who? Sorry, I couldn't catch.
Send me a message here.
Oh, okay. I
Okay,
get
if
it
you have
right now.
any problem, I'm with you until Professor Salar returns back.
Okay, now I get it. Okay. I think we have time. As far as I follow from the program,
yes, 2 minutes.
The presentations should start at 7 p.m.
Yes.
But if everyone is here or the first presenter is here, we may start. But we also can use this time to check the presentations.
Yes.
As far as I see, we will.
I'm a co-share with you.
Okay.
Okay.
Okay.
And there is Dr. Ferhati Kudau also. Dr. Ferhati is not yet here.
He's not yet here, okay. And we have, I think in the session, we will go through the presentations about AI, the impact of AI on architectural design process in the education of architecture. In the first presentation, as far as I see, we will see a presentation titled "Validating Artificial Intelligence for Restoring Bygone Urban Landmarks." If Darpil, I'm sorry if I'm pronouncing the names wrong. Is Darpil Saha or Professor Dhal Raval is here? Professor Raval is here. I think they're not in the session yet. Sevda Başar and Professor Zelal Çınar's presentation will be the next one, from black boxes to transparency, with the title. Yes, I see Sevda Başar among the participants.
Can you hear me?
Yes, I can hear Sevda, but I'm waiting for the first presenters because in the program it is written that the presentations should start at 7 p.m. So they may join later. We may use this time by knowing maybe the presentations, by checking the presentations and the presenters. The third presentation in the session will be the analyzes the use of artificial intelligence as digital tool in architectural design process. And Tobias Hanke, Jan Yoshio Kawasaki, and Professor Dr. Gregor Grunwald are the authors of this presentation. I'm not sure if you hear, you may tell us. And the fourth presentation will be exploring the impact of emerging AI applications on architectural production and experimental study in computational design studio. Ayşegül Çeltekligil will be presenting this one. And yes, I see Ayşegül among the Professor Ayşegül among the
Hello,
participants.
everyone.
Okay, and the last one will be innovative design synthesis, and Ferhati Kodoğa, I believe, also one of the presenters of this paper. And after these 5 presentations, we will have a discussion session for 10 minutes. Then we will continue with the last 4 presentations for this day, as far as I see in the program. And Professor Nedi, do you think we should wait for the first presenters? Yeah. I'm waiting for the Professor Saha and Raval. I'm planning to wait until 7 p.m. Then, if they're not here, we can go to the next presentation. Um, As everyone know, the AI is a hot topic in every discipline nowadays. So I'm waiting for the presentations. I'm very curious about the presentations on this topic. And if the presenters do not participate, we shouldn't show their presentations, right? I'm not sure. Should we?
No, we can work their presentations.
Okay. Let's. I think we can start the presentations. So
Okay.
if they
Show up.
Join, yeah, if they join later, we may ask our questions to them. So let me share my screen and let's start with the first presentation. And it's here.
Hello everyone, let me introduce myself, Professor Darpil Shah, with me, Professor Dhaval Rawal. We are from Anant National University, Ahmedabad. The title of our paper is Validating Artificial Intelligence for Restoring Bygone Urban Landmarks, the case study of Sardar Vallabhbhai Patel State. We are from a place which is famous for its amazing architecture, you know. Architecture, marvel, and societal impact all contribute to the need for their restoration. These structures embodied the historical architecture and social fabric of a bygone era. Additionally, many were designed with public use in mind, following specific principles and philosophies of architecture. Unfortunately, structures like the Sardar Vallabhbhai Patel designed by Korea and Milonas building designed by Corbusier, Prema Hall, designed by B.V. Joshi, face the threat of demolition due to structural damage. This is where technology like artificial intelligence can play a vital role. AI can assist in assessing structural damage and generating restoration proposals, ensuring these architectural gems and preserved for future generations. AI's involvement in the field of architecture and structural engineering will be crucial for the restoration of these significant structures. Artificial intelligence is like a vast and deep ocean, presents a complex but exciting field of exploration. In the world of architecture and structural engineering, AI's potential for innovation and invention seems limitless. So, as a powerful tool, AI can be harnessed across various industries. It excels at collecting data, analyzing diverse scenarios, and identifying patterns. For instance, integrating AI with BIM, Building Information Modeling, software allows for the creation and analysis of numerous design iterations, ultimately leading to optimal structural stability. Programs like Revit and ANSYS can identify potential issues within a proposed design from architects, structural engineers, and MEP engineers. by leveraging AI as a solution-oriented tool, we can effectively restore bygone structures through stabilization methods and generate comprehensive restoration reports. The restoration of bygone structures destined for heritage status presents several challenges. So a crucial question arises. How can we save this structure from demolition while preserving the architecture? Additionally, the demolition process creates significant amount of construction waste, negatively impacting the structure, the surrounding, and the environmental areas. So demolition is not a solution. This is where artificial intelligence can play a transformative role, where AI can assist in restoring structural stability by assessing the severity of the damage, where AI can analyze the data to determine the extent of structural damage within the building. Generating the restoration proposals, so where AI can create proposals for repairs and reinforcements based on the damage assessment. Optimizing restoration plans. AI can analyze various restoration options to identify the most effective and cost-effective approach. By utilizing AI, we can create comprehensive restoration reports that guide the process of restoring these structures. This approach not only preserves architectural heritage, but also minimizes environmental impact compared to the demolition. So we came with the case study, or let's say an example. So consider the renowned Sardar Vallabhbhai Patel Stadium, which is commissioned in 1960. It lies in the heart of Ahmedabad city. Designed by Charles Correa, architect Charles Correa, and the structural engineer Mahendra Raj, who also collaborated with Corbusier and B.V. Doshi to have very good and renowned architecture structures in Ahmedabad. The stadium boasts a unique and significant feature, like a 20-meter cantilever folded plate roof, the first of its kind at that time. The structure is also constructed into exposed concrete, where cast in situ seating further adds to its architectural merit. Beyond its architectural significance, the stadium holds a social value throughout the city. It hosted India's first international cricket match in 1981. The singers like Arijit Singh and A.R. Rahman have also performed through the concerts into the stadium. However, due to structural damage and deteriorating elements, its current use is limited to morning activities like walking, few county cricket matches, and the municipality corporation gatherings. So to regain its former glory and functionality, AI can be a valuable tool. AI can assist in assessing the structural damage, generating restoration proposals, and optimizing the process for a cost-effective and sustainable restoration. So here are the few images of structure where you can see the cracks and the deterioration of the structural elements throughout the structure, which has become very harmful to the structure by day-to-day life, and it is also risky for the public use also. So in October 2021, World Monument Fund also did a structural damage assessment for this structure, where they kept this stadium under the watch list in 2020. So they have prepared this whole document where they have highlighted the structural damages, the cracks, the deteriorating, spoiling of concrete through this map in and showed it into the structure. So this is a paper where we try to develop a methodology for further process, where in the stage 1, you can see it's a retrofit workflow has been prepared. In stage 2, beam goals are decided, retrofitting processes, developing the detailed use of materials, and lastly, the exchange of information. So here is a methodology for the research. So in stage 1, increase the effectiveness of the design, where structural system, lighting, electrical, and mechanical system will be incorporated into the ANSYS or the Revit software, where analysis of the building performance will be checked, capturing the existing condition and capture the structural damages into the building. Develop record of the final building design. So this will be our second stage 2, where the model will be monitored with the structural damages and the maintenance, which is developing throughout the duration. In stage 3, improve on-site coordination and efficiency. We will coordinate this model with the on-ground conditions, and along with that, the construction documents will be prepared, like retrofitting plan, the restoration documents will be prepared. Value engineering and life cycle cost evaluation. Analyze structural strength, how to use the structure after the restoration or the retrofitting. Preparing the value added report for restoration, and analyze the construction waste and the carbon emission before, along with the demolition. So demolition will not be done, but what will be the changes if the demolition is not proposed? So here we can say that our first stage 1, where the modeling is happening in Revit. Then in stage 2, where we are monitoring the structural damages happening on the site, and we are incorporating these things into the models. And lastly, the use of AI into the comprehensive restoration plan, which will be done with the help of this recommendations provided through the restoration plans and the proposals, which will be preparing at the end of this research.
Thank you, Professor Saha and Raval. We will ask our questions in the question and answer sessions, and now we will go to the second presentation to use our times more effectively. All right. And second presenter will be Sevda Başar. Yes, it's here. Now I'm going to share my screen.
Hello everyone, my name is Sevda Başar and thank you for having me today. The title of our presentation is From Black Boxes to Transparency, the Evolution of AI in Architectural Design with Co-Creation Tools. And this research is part of the ongoing thesis study. The question this research tries to answer is, how does the integration of artificial intelligence, AI, into architectural design, particularly through co-creation tools, affect the design process? And what role does the black box opacity play in the predictability, controllability, and overall efficacy of these tools? As architects designing more in digital space, a new language has formed between computers and designers. The widespread use of AI has caused a big change in architecture, creating a new way for designers and AI to communicate. The main question is how AI integration affects the design process. Additionally, the research will explore how the black box opacity impacts the predictability, control, and effectiveness of these tools. With co-creation tools, it's possible to obtain an output from specific input, which can be visual or textual. However, due to black box nature of AI, the predictability of resulting product is limited. This lack of predictability poses a challenge in AI-assisted production. This study will address the challenge of co-creation and examine one of the possible solutions, known as explainable AI, XAI in the literature. This study aims to explore how AI changes architectural design processes by looking at the impact of integrating AI tools. Investigate co-creation tools like image-to-image, text-to-image, and 2D to 3D applications, assessing their potential and challenges in shaping architectural innovation. And this research adopts a systematic approach to understand the integration of AI in architectural design, particularly through co-creation tools. The study involves a comprehensive review of existing literature and practical testing of various AI-enabled co-creation tools. The data collected will be analyzed to evaluate the impact of AI tools on architectural design processes. The findings will be synthesized to provide a comprehensive understanding of AI's role in the field of the architecture. At this stage, the challenge of implementing AI in architecture and potential solutions will be explored. One of these challenges is the opacity, often referred as black box. According to Kotnik, the black box can be seen as a metaphor for computational processes that are used in architectural design. He argues that the black box can be problematic as it can lead to lack of understanding of how the design processes work and can limit the ability of architects to innovate and experiment. Kotnik suggests that one way to address this issue is to develop new tools and methods that allow to architects to better understand and control the computational processes that they are using. One of these methods can be XAI. XAI makes AI system clearer for everyone using them. This is especially essential when dealing with complex AI models that aren't easy to understand. By making these systems more transparent, XAI allows users to see how decisions are made and on what basis. When used in architecture, XAI can help architects understand the tools they work with better and gain more control over them. Research has shown that XAI could potentially clarify the opacity of the black box in various technologies, but it's not yet implemented in architectural tools or text image generation tools. This situation is expected to evolve with further technologies advancements. Through hands-on experiences, the research shares observations on co-creation with these tools. From this perspective, the question arises, can I have more control over tools with XAI so that we can co-create? Firstly, I look at the 2D creation tools that many of us have tried before, and I examine that I only have limited control by changing the prompts or visuals. For example, controllability is limited in AI tools that produce images from prompts, and we have limited control over the final products. From the beginning, my reason for exploring XAI was to have control in co-creation process with AI in design. And I saw that as AI tool for producing 3D improved, controllability was increasing. We were co-creating beyond the prompts. For this reason, I want to show the examples I made about how designers can get involved with 3D tools, which are Stable Diffusion Fluid Depth, GH-Python, CompUI, and TripleAI. First of all, in this example, 3D shapes were produced with Python's Grasshopper interface. The co-creation process was experienced by writing Python codes with the help of ChatGPT. First, ChatGPT was asked to create a torus node shape by writing Python code. The generated code is pasted into the interface and the model appears on the screen. This shape can be changed simply by playing with the parameters. ChatGPT assists the steps. However, achieving the desired result in single prompt was created by trial and errors. However, by co-creating with AI, we can see that we can produce 3D without knowing the coding. Another tool is SoyDepth. SoyDepth is a deep learning model for metric depth estimation from a single image. This tool is capable of depth predictions, transitioning from an image to 3D, or converting a 360 panorama to 3D. This image shows the depth predictions. We can see an example of how can AI create a 3D model from depth map. It generates 3D prediction using depth map analysis of image. Currently, the results are not very accurate, particularly in predicting the back facade of building. However, improvements are being made in this area. In this example, AI was used to produce a 3D model in a similar logic. Initially, work was done on the desired image with ChatGPT. The output product was then converted to 3D in another application called TÜRKİYE. At this stage, new features were tested in concerning AI's ability to generate and predict 3D models. The model obtained from TÜRKİYE can be exported as a point cloud, and modifications can be made in other design programs like Blender and SketchUp. In the example above, the output product was transferred to Blender. Like TÜRKİYE, we can see AI's capability to predict 3D models. Being able to edit these models provides us with a user interface, which enhances explainability and controllability. It essentially makes the tool's black box more transparent. Another example, a model created using TÜRKİYE was created in Blender and then rendered through Lumion. This visual was reprocessed, and by entering the desired prompt in another AI tool, a reverse process was followed to see what other result could be produced with these tools. In conclusion, in architectural design, combining AI with co-creation tools has brought big changes. The study looked at how AI affects the design process, especially dealing with the challenges of black box issue. By checking out co-creation tools and exploring XAI, the research aimed to learn more about how humans and AI work together. The study underlines challenges related to black box and XAI principles to highlight transparency and clarity in AI-powered design, and underlines the importance of trust in AI decisions and focuses on predictability, controllability, and impact of co-creation process.
Thank you, Sevda and Professor Zelal Çınar for your presentations. And now we will go to the next presentation and analyzes the use of artificial intelligence. Now I'm going to share my screen.
On the topic analyzes the use of artificial intelligence as digital tool in architectural design process. We welcome you to join us. The leading persons behind this paper are Professor Dr. Grunwald, Professor of Design and Construction Management at the Department of Architecture at the Jade University of Applied Sciences in Oldenburg, Germany, and my colleague Jan Yoshio Kawasaki and I, Tobias Hanke. We are both research assistants and all three of us working on the same research project. In 2023, as part of the research project, students investigated how artificial intelligence, or AI for short, can be used as a tool in the architectural design process. Since our study, the use of AI has become increasingly common in the everyday work of architects, and is now established as a tool in various software solutions. In today's presentation, we use the results to identify where AI can be located and used in the architectural design process. At first, a short description for the presentation structure. So, we start with an introduction of the research project Aufladen and motivation behind the topic. The next step describes the analysis of the design process and assignment of tools as a base to go on with the method. Step 3 shows the method of using AI as tool in design process to answer the question. And the last step shows the results and gives an outlook to this topic. The presentation gives a rough overview of the topic, so the more detailed analysis will be available when the paper is published. In the research project Aufladen, we develop a digital web portal where students have the opportunity to test and expand their knowledge in the context of the digital transformation of the construction industry with a focus on building information modeling, or for short BIM. To research current topics, we developed also space for students to experiment. We call this Aufladen Lab. And one area of the slides we talk today is AI. So the development of this topic came up with the release of the AI model ChatGPT and DALL-E, developed by OpenAI. The release of these two models brings a kind of technical revolution, and the AI became indispensable from one day to the next. It didn't take long for certain AI models to find their daily use in the everyday lives of architects. Due to this development, the question came up how certain AI models can be used and in which areas of the process they are located. To answer this, we start by analyzing the design process. Architectural design is a process that's difficult to force into systemized paths or typologized processes. So architecture is not created in a vacuum. As a rule, it is created as a reaction to the context in which it becomes a structural reality. It accommodates functions, lends expressions and design to a task, and can be experienced through its construction and material. This rule forms element, and with the description come different keywords to our mind. And these keywords are used to form parameters. And all parameters combined lead to the result of the design process and the realization of a project. With the assignment of tools to these form parameters, the question is where AI is located as design tool in the whole process. And with pick of tools, the students created topics to analyze the verification and usability of AI in the design process. So to explain this method in more detail, here's an overview of two case studies. In first case study, DALL-E 2 was used to investigate if AI can generate structural details. The aim of the case study was to find out whether the use of DALL-E 2 can accelerate and optimize the works process. Furthermore, the results were evaluated with regard to their suitability. So at first, when it comes to text description entered, the AI model generates images. To do this, the AI breaks down the text into semantic elements and uses generative models to generate images that correspond then to the descriptions. We see that DALL-E 2 is able to create the visualization of a structural detail by the request, but it's not able to create a usable structured detail that fits 100% of the user's requirement. So the result of the investigation showed that AI is able to create an image that reminds the viewer of a structural detail. But by taking a closer look at the generated images and repeating the process, the analysis reveals that DALL-E 2 is unable to create a structural detail for use in the design process of architecture. So the results are not usable. In another case study, ChatGPT was used to investigate whether it would be possible to create a room program for a workshop building. So for beginning, the student asked ChatGPT to create a room program for a workshop building with specific parameters. The AI has defined areas that should be output in more detail with a further request. So the results were cross-checked by the student in a CAD software. The result is that the AI is able to design a room program, so it works. And with show of these examples and this method, we come up to the last step, the verification and the conclusion. The design element is located in the early phase of the design process, where creative ideas are developed to define the general character and direction of a project. At the same time, the functional requirements of a project are identified and analyzed during this phase. This includes also text and context. Architects conduct utilization studies, space programming, and functional analysis to understand the specific needs and requirements. And the role of constructions and materials is already taken into account in the early design phase, but it's only consolidated in the later phase of design process through the elaboration of construction and material related details, and is located in the area of realization. So if we put this information into a matrix, the matrix shows in relation to the results that AI is more usable as tool in the early phase of the design process. And as the ideas are consolidated, the need of AI as tool decreases more and more. Furthermore, it can be seen that text-to-text models such as ChatGPT can be used in the elements text, context, and function, while text-to-image AI models are preferred in the design element. A more detailed explanation can be read in the paper to this topic. So as an outlook, it's proved through the results that the use of AI in design process for concept development is acceptable. Building on this, it's interesting to use AI in technological areas where digital skills are missing. For example, in the field of augmented reality to produce complex structures with softwares like Rhino and Grasshopper. We hope that the presentation has provided sufficient insight into the topic, and thank you for your attention. Thank you.
And thank you for your presentations. Let's move to the next presentation, exploring the impact of emerging AI applications on architectural production. Again, a very similar topic. And Professor Ayşegül Çağtekligil will be presenting.
I hope one day, but now I'm just PhD candidate.
Okay, no problem. So it's just.
Thank you, Funda Hocam.
Okay, I'll start.
Hello, everyone. This is Ayşegül Çağtekligil. Today, I will be presenting my paper entitled Exploring the Impact of Emerging AI Applications on Architectural Production, an Experimental Study in a Computational Design Studio. You can see the content of presentation here. Emerging artificial intelligence technology is active in every field in the new millennium due to its speed, creativity, and infinite variation generation. Emerging AI technology contributes to the architectural production and evaluation process by leading the development of machine learning, deep learning, generative network algorithm, and computer-aided design. AI technology is used in the design disciplines in states such as idea generation, design state, visualization, collage production, etc. The contribution of AI to architectural production processes is an emerging field that has been studied conceptually and empirically in recent years. The study aims to explore the contribution of AI applications to production in the stage of analysis, synthesis, design, planning, and visualization in the architectural studio. The study will reveal the contributions and negative aspects of online AI applications to the architectural production process of students in architectural design education in an experimental way. In addition to these, the study aims to integrate the developing AI technology into the architectural design process in architectural education and to increase student interaction with AI. The study consists of 3 stages: literature review, experimental study, and survey. Firstly, online AI applications were researched and the tools to be used were determined considering the limitation of the study. Then, online AI applications were integrated into the first 7 weeks of the 5th semester elective course, Computational Design Studio at the Beykoz University. 5 months after the study, a survey was conducted on student interactions with AI tools and feedback data was collected. The online AI application and its capabilities were briefly introduced to the students at the beginning of each lesson. The exploration of the program's capacity and tools was left to the students' creativity for 4 hours. In the 7th week, students were given a sheet and evaluate the positive and negative aspects of the AI applications they used. In this chapter, findings from the sheets and workshop observation are presented. In the analysis phase, AI tools were used by the students to collect data on the history of the field, determine functional requirements, examination of different concepts, receive data from regulation, and etc. During the design stage, image-to-image and text-to-image methods were tested. With AI application at the design stage, many design alternatives can be created in second with the keywords determined by the students. You can see the design ideas that the students who is building a hotel project on the edge of the cliff receives from AI tools and how these ideas are reflected her projects. Another method of design generation with AI is image-to-image generation. Different alternatives of the student project in the first image were produced by changing the impact values of image and keywords on the project. You can see another sample here. Different alternatives for the facade of project can be generated quickly by changing the keywords and visual impact value. Many students state that they used AI tools at the preliminary design stage for facade development and their projects. And you can see the redesign of the facade of students' kindergarten project here. Different online AI tools that can generate plans have been tried, but none of them have produced positive results. Online AI applications are generally successful in producing lifelike image. These were used by students in collage production and different visualization stage. Online AI applications may detect some elements incorrectly. The image produced may have to be corrected through another user-controlled program such as Photoshop. It is very important to enter the right keywords in AI tools. Here you can see that the image on the right is rendering 2 different ways, interior and exterior. AI tools can also be used in visualization stage or adding architectural production to posters. According to the survey data conducted 5 months after the study, students continue to use online AI applications effectively in analysis, design, and visualization after the study. Students also state that they were using different AI tools and sharing their experience with AI tools to their friends from different semesters and universities. This experimental study representing pioneering research and offers new insight into the integration of AI applications in architectural education. The observation and evaluation studies conducted during the courses related that emerging AI applications bring potential to the traditional architectural design process. In this context, it is very important to try to integrate this rapidly developing technology into the production process of architectural education. Through AI tools, students can produce concept ideas that are difficult to express with their existing 2D or 3D competencies. The fact that AI application inspired the designer by generating new design scenarios is an indicator of a new era in architectural production. The criticism of the ChatGPT used in the analysis stage were generally related to the poor quality of the resources and the AI's inability to understand the questions. Criticism of the AI application used in the design and visualization stage were the difficulty of using keywords and misperceived items. AI tools which are used in different stages of architectural production and architectural education have yield positive results in different stages of architectural production by enabling quick production, opening different horizons to designer with its inspiration and contributing to the quality and speed of visualization. After the 7-week study, it was observed that students integrated online AI applications into their project production processes. Interacting students with AI is important for architects to produce potential productions in these fields in the future. Online AI applications cannot produce on its own without user making a guiding decisions. And this makes the use of online AI applications in architectural education useful and creative rather than dangerous. Nevertheless, it is also possible to talk about a possible risk of plagiarism and sameness with the development of tools in the future perspective. This study was conducted only with AI applications that given a certain amount of free tokens. AI applications that require surveys such as Discord were not used due to the use of university-connected internet. In future studies, development of AI applications used in the study or the use of different applications will offer new perspectives. You can see the references here, and thank you so much.
Hello, my name is Qudwa Farhati, PhD candidate at Constantine III University, Algeria, and today I will present my research about enhancing physical outcomes throughout human-centered design. The economic benefits of salutogenic architecture in public design principles in healthcare facilities is an innovative approach for promoting health and well-being throughout the design of our built environment. Salutogenic design places emphasis on the incorporation of key elements that have a profound impact in our physical and mental well-being. These elements include natural light, access to nature, and the use of materials and colors that foster a positive and healing atmosphere. By implementing these principles, we can witness a transformation in patient incomes, which reduces stress and anxiety, faster recovery times, and improved overall health outcomes. Well, it's not only patients who benefit from salutogenic design, but staff who works at the hospitals and healthcare facilities also experience a significant improvement in their well-being and job satisfaction when working in environments that prioritize their needs. This positive effect on staff satisfaction can lead to a reduction in turnover, ensuring a stable and motivated workforce. From an economic standpoint, salutogenic design principles offer a cost-effective way to enhance the effectiveness and efficiency on health services. By creating environments that support healing and well-being, we can potentially reduce healthcare costs in the long run. Despite the growing interest in salutogenic design principles, there is still a dearth in the evidence regarding their economic benefits in public healthcare facilities, particularly in Algeria. Therefore, our study aims to fill this gap by investigating the economic advantages of incorporating these principles in Algerian public healthcare. How do salutogenic design principles impact the economic benefits of public healthcare facilities in Algeria? The main objective of this study is to investigate the economic benefits of salutogenic architecture in public healthcare facilities in Algeria, going throughout the following secondary objectives. First is to explore the perceptions of staff and patients on the impact of salutogenic design principles on healthcare facilities, then to investigate the effect of salutogenic design on staff well-being, patient experience, and overall cost of healthcare facilities, and finally to provide an evidence for the potential cost savings and other benefits of incorporating salutogenic design principles in literature review. We have summarized the key points on salutogenic design principles in healthcare facilities, which is an approach that aims to promote health and well-being through the design of the built environment. The literature highlights several key elements on salutogenic architecture. First, the incorporation of natural light, then the providing the accessibility to nature throughout green spaces and views of nature, also the positive and healing atmosphere, and the flexibility and adaptability are also key principles. And lastly, the salutogenic architecture aims to foster connection and community by providing spaces for social interactions, communal areas, and gardens. Some key quotes in what concern the implementation of salutogenic principles in healthcare facilities is going from Osterberg, 2011, patients in a hospital with salutogenic design has a shorter recovery time and reported a higher overall satisfaction with their hospital experience. Craig said that staff in salutogenic hospital reported higher job satisfaction and a lower turnover rate compared to staff in a traditional hospital. And the last research from Smith and al. In 2021 confirmed that salutogenic design in healthcare facilities can also lead to a reduction in energy consumption, which can lead to cost savings and environmental benefits. We see that studies have shown that patients in salutogenic hospitals experience shorter recovery times and higher overall satisfaction with their hospital experience. In nursing homes with salutogenic design, residents have a lower risk of depression and report a higher quality of life. Studies have shown that salutogenic design principles can theoretically lead to reduced healthcare costs and improved patient outcomes, but there is still a gap in the literature about the implementation in public healthcare facilities and the expected outcomes. The framework for understanding the economic and well-being benefits of salutogenic architecture in healthcare facilities can draw upon several relevant theories. First of all, we have the Bophilia theory, which is proposed by Edwards, suggests that humans have an innate affinity for nature and that exposure to natural elements such as green spaces and natural light promotes well-being and health. The second theory is the environmental psychology, which suggests that the interaction between individuals and their built environment. The theory of environment in psychology, including attention restoration theory and stress reduction theory, provide insights into how salutogenic design principles can positively impact mental health, stress reduction, and overall well-being. Also, the evidence-based design, which is a theory that emphasizes the use of research evidence to inform design decisions. And finally, the cost-benefit analysis, which is an economic theory that assesses the costs and benefits associated with a particular intervention or design decision. These theories suggest that integrating natural elements, considering psychological well-being, incorporating research evidence, and evaluating the economic feasibility can optimize the health, well-being, and cost-effectiveness review and the theoretical framework. A conceptual framework can be developed to support the investigation of the impact of salutogenic design principles in public healthcare facilities in Algeria, which includes the independent variable, which is the implementation of salutogenic design principles, and we have 4 dependent variables, which are the well-being of patient and staff, the facilities, the cost savings, and the overall sustainability in healthcare framework led us to formulate the 4 research hypotheses, which states that the implementation of salutogenic design principles in public healthcare facilities in Algeria will lead to improvement in the well-being of patient and staff, will lead also to the improvement in the efficiency and the effectiveness of healthcare facilities. It's going to lead to the cost savings in terms of healthcare facilities, and finally will lead to an improvements in the overall sustainability of use a mixed methodology using a checklist and a survey as the primary data collection methods. The survey will include a set of questions that will be used to investigate the economic benefits of salutogenic architecture in public healthcare facilities in Algeria. Population identification, which goes to 10% of the total number of healthcare facilities, which give us 60 public healthcare facilities divided on hospitals, specialized hospitals and university hospitals. Then the facility 13, which uses a checklist with 25 criteria grouped in 5 domains, which are access to natural light, access to nature, positive and healing atmosphere, flexibility and adaptability, and finally connection and community. Then for the data collection, we use a QR code questionnaires which make the data collection easy for both the groups. Going to the data analysis, where we use the descriptive statistics and t-test to measure the mean difference between the compliant and non-compliant groups, compare the effect of salutogenic principles on various aspects in the healthcare facilities using t-test for the 2 groups. In group 1, it shows that higher average score in well-being with 1.8 compared to group 2 with 1.6, indicating slightly higher levels of well-being of patient and staffs. Going in terms of efficiency and effectiveness to group 1, which demonstrate a higher average score with 4.2 compared to group 2 with 3.7, indicating a more positive impact on staff experience. Also, for both groups, a positive effect on overall costs, with group 1 showing a slightly stronger effect. Finally, in terms of facility of sustainability, group 1 has a higher average effect with 3.5 compared to group 2 with 2.3, indicating a stronger impact on the overall sustainability of the facilities. These findings suggest that the implementation of salutogenic design principles can have a significant positive effect on multiple aspects of healthcare facilities, which support the explore the effect of salutogenic design principles in healthcare facilities. The results demonstrated that implementing these principles positively influences various aspects, including patient and staff well-being, efficiency and effectiveness of healthcare facilities, overall costs, and facility sustainability. Incorporating elements such as access to natural light, natural positive atmospheres, and flexibility can lead to improved patient outcomes, staff satisfaction, and operational efficiency. These findings highlight the significance of integrating salutogenic design principles to create a supportive environment that promotes well-being for all stakeholders in healthcare facilities. By considering these principles, healthcare facilities in Algeria can enhance that well-being in individuals, optimize resource utilization, and contribute to the overall sustainability of the healthcare system. Thank you for your attention.
Thank you. Right on time, as far as I checked. Sorry. I have YouTube videos opened. Okay, we listened to presentation mostly about AI usage during architectural design process. Also, the first presentation was about using AI methods on the process of reconstruction of bygone assets or cultural heritage. And the last presentation was about the cellogenic design of hospitals or healthcare facilities. Is there any, first I will give the word to you. Is there any questions to the presenters among the listeners? Okay. If there is no question from you, I will ask my questions. First to Professor Saha, if it's okay. Thank you for your presentation, Professor Saha. And first, I would like to ask, and during your the process of your project, and you mentioned that you also benefited from AI tools, maybe integrated to the maybe the BIM tools. And which was the main AI tool during your process you benefited the most, and from which aspects maybe you tell us how it facilitated your process?
So, hi everyone. So it was nice listening to everyone's presentation. So my research is based on the damages which are occurring to the structural damages which are occurring to the structures which are built in 1990s, before 1990s or between 1950 to 1990s. Those structures which are becoming very much unstable because of the structural damages occurring to the time to time using that structures, and because the atmospheric conditions are also harming the structures, and the tools like Revit or the ArchiCAD on which we can put the inputs like putting the damages or giving them the structural constraints, then the analysis of that structures will become easy to find out the lifespan of the building. And after doing that, we can give this plan to the local municipal body or the structures which are being undertaken into the consideration, so they can go with the retrofitting process or just not doing the demolition of the process. So my example was the Sardar Vallabhbhai Patel Stadium. So that stadium is now under threat of demolishing because of the cost of the uh, retrofitting every few years. So it is being demolished, and to save that, the AI technology can help out by giving the retrofitting plans and different aspects, so that we can save the building as well as we can save the environment by not creating a more construction waste or to demolish or to save the environment.
So thank you. So you are actually suggesting a cost optimization maybe for the repairments. Can you? Is something? Okay. Thank you. And is there any question? Is there any more question for Professor Saha? Okay. Thank you for your presentation. And if not, then I will move to the next presentation and Sevda, and ask my question to the presenters. And you actually discussed about several AI tools, and some of them I was not even aware of. Very new and innovative methods, especially I think the ones which can create 3D models from the image. And but you also how can I say, you also advocated that architects should some control over these AI tools. And can you a little discuss this more? Do you really think the architects need to have control, because they, as far as I see, they already have very strong products, very strong results? So is it really quite important for architects to have control, or just use the tools?
I think architects right now, it's limited control over the tools, because the tools interface, like they just have get an input like a text, a prompt, and we have just an output. And I think it's limited, and maybe with the AI, architects more control over these tools, and we can have more control, and maybe we can get better products.
Or maybe we can just understand more deeply the way of their working. I think they also changing our understanding of our understanding of creation, or creationism, and maybe I think maybe we can switch our perspective. We will need to switch our perspective in the future, probably. I don't know, what would you say to this comment? So just a comment.
Thank you.
Is there any more question to Sevda? And thank you. And next presentation was very similar. It was going through an AI tool. I don't know if TÜRKİYE or any other authors is here of the presentation. Okay, let's switch to the next presentation. Then Ayşegül presented the use of AI tool, this time in the education process, in the studio, in the education process of architectural discipline. And I would like to ask to Ayşegül if how was the students' reaction to these tools? Like, did they accepted the tools and start using immediately and very easily, or the students if they have resisted in any way to use these tools? Like, is there any resistance against these tools?
Actually, thank you for your question. Actually, I waited the resist from them, but they are very quick and easy program, because they are online applications and very easily using like Instagram. That's why they are adapted very easy. This study made on third grade students, but I see they teach other semester students too. This is interesting, and now every student on the university using them. It's different results for me.
And in which aspect do you think the results was surprising for you, the most surprising for you, which aspect?
Actually, architectural design is not just an image or mass design. There are millions of parameters like social or environmental data. And we can't add these parameters on the online applications. Okay, these online tools help designers for in giving new horizons and quick visualization. That's good. And third graders can understand this, but first and second graders can't understand this very well. There is why AI tools will be treated to their learning duration, because they don't yet know how to use these environmental or social parameters, and they don't know exactly how they should be placed in the side plane.
Yeah, thank you. Thank you very much for your comments, because these are very strong views for the AI tools. Thank you.
Thank you.
And last presenter was Kuda, and is she or any other authors of this presentation is now among the listeners? I think they are absent as well. And thank you. Like now, we can proceed and start watching the next presentations if there is no other question. Okay. Then I will continue with the presentations. The next presentation will be pedagogical strategies for architecture against artificial intelligence, which is
Hello everyone, my name is Maharshitula and I am here to present my paper upon.
Sorry, I think is there okay. I'll start again.
Hello everyone, my name is Maharshitula and I am here to present my paper upon pedagogical strategies for architecture against artificial intelligence, AI. Obviously, we know AI and already we know that AI applications already started to transform the business methods in different disciplines. So here, definitely my research focus is not on introducing the AI as far as possible. But the point is, let's say if you focus about the architecture, that is the core disciplines. And after, let's say, multiple discussions with the practitioners, with the academics, with the particular professors, even during the studios with different students, there are multiple different questions that those arise during this particular analysis. And obviously, out of all the questions, the common question that if I try to create as a statement, then that it is, what is the feasibly justified level for acceptance and implementation of basic principles of AI into the education and simultaneously in the practice of architecture? And definitely on that base, the objective of this research is to define how AI tools and architectural knowledge can be integrated to learn and practice architecture, and also to enhance specific strategies that can come after proper synergy of AI and architectural ethics. Surely, we can sense here that if architects can use the opportunity to utilize AI in various phases of design and construction, then definitely the nature of the practice will change irreversibly. But this process ideally should be started right from the education, and it should be implemented first as a core pedagogical strategy as far as possible. So that's on that base normally I started my research and analysis as far as possible. So let's say if we focus first on the basic fundamentals or principles that we normally take upon during the teaching and learning methods into the specific field of the architecture. And definitely any particular this methods normally starts globally from the project-based learnings. Then definitely it follows up with the design studios, interdisciplinary learnings, experiential learnings, critical thinking theory, digital tools and techniques, definitely. Sustainability and environmental awareness, communication skills, research and innovation, and lastly it follows up. It delves into the typical professional practice, and this is where normally this is a proper hierarchy and sequence that we follow to prepare the students to become the skilled and responsible architects for the field as far as possible. So in these ways, let's say if I talk about integrating the AI tools with architectural knowledge, firstly in the practice, there are several ways. Let's say if you talk about the design assistance, if you talk about the generative designs, if you talk about project management, time management, the reality, the virtual reality, the natural language processing, and the knowledge discovery. This is the first segment, the actual segment of the architectural practice where actually the integration is required. But on other hand, if you talk about education, so definitely the ethical consideration, design considerations, sustainability, environmental ethics, cultural preservations, history, community-based engagement, transparency and the accountability, cross-cultural based collaboration, that is the most important thing, and the data ethics. These are the several ways and strategies where normally we can easily integrate the AI tools as far as possible. These are the broader ways, views where how we can easily enhance and based on the capabilities and based on the ultimately with the focus of the efficiency on the base we should integrate the AI tools as far as possible. Let's say if we talk about the basic features, certain features of the AI, and definitely we know that one of the core features is the real-time rendering features against, let's say, the actual the rendering that used to happen in the past times. Definitely this particular tool actually can give a proper unprecedented based level of realism as far as possible. So obviously in terms of, let's say, presentation, in terms of designing, in terms of integrating the technology, this is not just a beneficial base for the design process, but it is also a game-changing tool for the overall presentation as far as possible. But why? Because definitely in the past we know that rendering processes could be a painstaking and time-consuming based process. But here, after this powered by AI, it changes all of that, and this technology enables instant visualization and in terms of design changes dramatically, accelerating the time as far as possible, and the ability and rapidly iterations based refined design solutions. So this can be one particular important tool. There are another tool like VR and AR technology. Let's say, obviously we know over here, let's say instead of static 2D drawings and 3D models, architects can easily now use the VR to create a fully immersive and interactive presentations for the designs. And here definitely it enables architects to superimpose a 3D model of a proposed design onto a real world environment, and further enhancing the understanding of how the structure will interact with its surroundings. And definitely this here, it can the viewers can have a walk around inside the building before the ground is even broken. So these are the tools definitely the practitioners can easily involve in the design. So simultaneously these tools can easily be a part of their overall education, how they can involve these particular techniques into their project criteria as far as possible. Because as we see, the overall our learnings, the pedagogy normally actually turns into the professional practice as far as possible. So this is where normally there are certain features of this thing. Also, one most important feature of this particular AI category is that it is generative adversarial network, that is a GANs, and that is also making waves in terms of visualization as far as possible. Why? Because normally it creates a proper data-centric work. Let's say it doesn't matter if we talk about smart building operation, let's say if we talk about automation, if we talk about construction management, building construction industry, design and visualization, structural design and analysis, material design and optimization. Here, all over this particular considerations are the part of one particular field, and there are multiple allied fields and multiple allied thinkings are there. So definitely this particular feature is actually helping in terms of considering the data and the samples. And after that, it generates this data, it generates particularly fake samples, it helps in terms of discrimination, and after that it gives the correct value of the particular design fundamentals. So this is the most important tools for the AI category as far as possible. There are multiple other tools for in terms of AI, how it can be in help in terms of design and innovation. But after that, let's say integrating and knowing all these features, the most important thing is what are the challenges in terms of the creativity as far as possible. So here, let's say if we talk about most importantly in terms of, let's say, enhanced exploration, obviously multiple explorations are obviously will be the part of the if we try to integrate the AI into the efficiency. But over here, definitely there is a risk of over-reliance, and that is a risk of compromising the ethical consideration. And definitely the impact of the AI on the creativity in the design process depends on how it is implemented and integrated into the creative workflow. So on another side, definitely after knowing these particular fundamentals, major typical question arise over here. If anyone can design anything anywhere instantly anytime, then why should one study the architecture? And definitely here we know that architecture goes beyond the act of designing in the buildings. Apart from the data-driven design, apart from the typical iteration, typical pattern recognition, obviously if we talk about the contextual understanding, design thinking, expertise, techniques, creativity, spatial awareness, that is the most important thing, sustainability, and the human-centered design specifics. So here, definitely if we talk about the technology has transferred the way architects work, but the fundamental principles and the skills taught into the architecture, those remains same, irrelevant as far as possible. So now the question is, Will AI be able to shape up the placemaking experience along with the building that an architect can? Obviously, AI has a potential if we talk about the data-driven design, if we talk about the personalization, if we talk about the resources and the flexibility. Obviously, AI has a potential, but these qualities are difficult if we do not have the capability to create the balance. So that's what the major question over here is. So now the conclusion on this overall analysis is based upon the level of the acceptance and the implementation of basic principles of AI in education and practice of architecture. Obviously, in terms of education, we can say that its ability to enhance the learning outcomes, that is the most important thing, to prepare students in terms of evolving the demands. And in practice, it should be justified by its potential to improve the efficiency, quality, and the sustainability. So overall, this integrated in overall manner, it should be the part of the education and practice. And apart from this, definitely, as I said earlier, ethical consideration, that is the most important thing, with the collaboration approach with other disciplines and with multiple thinking approach, because it is not a one central thinking process. It's a multiple thinking process as far as architecture is we are talking about. So the continuous evaluation based on this should be there. And lastly, there are positive impacts, efficiency, precision, exploration, but on other side, there are certain negative effects also, like over-reliance, loss of craftsmanship, limit of creative thinking, standardization, reducing the uniqueness. These are the typical negative effects of the integration to the AI as far as possible. So on that base, the last thing, how to achieve the desired level of outcome. Obviously, it is important for architects to strike a balance between using tools and techniques to enhance their creative process and relying on their own creative thinking as far as possible. So that's what normally you see throughout this particular, multiple segment of the industrialization in terms of mechanism, mass production in terms of automation and revolution-based category as far as possible. The balance is quite important. So that's what the narration of my overall research is. And so that's what the way to create that particular feature next, after integrating the AI into the practice as well as education. But as I said earlier, rightly, it should be started from the education itself, first of all. That's it. That's the feature next. Thank you.
Thank you. I will move to the next presentation, but I cannot see any of the presenters among the listeners. If you are here, please tell me during the question sessions, and so we can ask our questions. Maybe I am wrong. And the next presentation. Okay.
Welcome to our presentation on the integration of artificial intelligence and large language models for enhancing building information modeling analysis, specifically through IFC model interpretation. My name is Leon Gröhlmeier, and I'm excited to share our research aimed at transforming how we interact with BIM data. I would like to express my sincere gratitude to the Offline project for their invaluable support and funding. Their commitment to fostering digital transformation in the construction sector has been instrumental in enabling our research and pushing the boundaries of educational and practical applications in BIM. In the rapidly evolving digital landscape of the construction industry, building information modeling has emerged as a transformative force, revolutionizing project management, design, and collaboration. Despite its widespread adoption and significant benefits in terms of efficiency and cost reduction, BIM faces substantial challenges, particularly in terms of accessibility and usability. A central hurdle is the industry foundation classes file format, which, while integral to BIM's functionality, remains complex and often impenetrable without specialized software. This complexity not only restricts its use to a niche group of professionals, but also impedes broader adoption and the potential for innovation. Our research seeks to dismantle these barriers by leveraging advanced artificial intelligence techniques. By integrating AI, specifically large language models, Into the BIM process, we aim to democratize access to BIM data, enabling a wider range of professionals to engage with and benefit from this powerful technology without the prerequisite of specialized training or tools. This approach not only simplifies interactions with complex data, but also enhances the overall utility and scalability of BIM in the construction industry. Our study is centered around a crucial question. How can artificial intelligence, specifically ChatGPT, be leveraged to facilitate interaction with the data contained within IFC files? IFC files are the standard data format for BIM projects. Holding intricate data crucial for the construction industry, but often difficult to access due to technical complexities. Our goal is to simplify this interaction, making it possible to inquire about BIM model details such as dimensions and quantities through natural language queries. To address this question, our approach was straightforward. We utilized ChatGPT, a pre-trained large language model, to interpret and generate responses based on IFC file content. This was not a traditional AI deployment with multiple models and fine-tuning. Instead, it was a trial and error process using ChatGPT. Our process was highly iterative. We interacted with ChatGPT by continuously providing specific scenarios and error reports, then adjusting based on whether the output from ChatGPT was accurate or not. Our adjustments were based directly on the practical outputs of ChatGPT, testing whether it could handle the tasks we set out. Our initial experiments involved directly interacting with ChatGPT to interpret and analyze IFC files, which was a foundational test to evaluate ChatGPT's initial handling of BIM data. Unlike traditional AI applications, there was no model training or architecture adjustments, just direct queries to ChatGPT using a specifically prepared IFC file that contained only a limited set of columns, for example. This primary challenge was the model's initial inability to accurately parse and interpret the IFC data, often misunderstanding the structure or giving irrelevant responses. Instead of training, our approach was iteratively refine the type and structure of the queries we posed to ChatGPT. We began by uploading a PDF that outlined the IFC hierarchy in an effort to teach ChatGPT about the architecture-specific vocabulary and data structuring. Despite this effort, ChatGPT struggled with the complex queries, initially reflecting the limitations of its pre-trained knowledge base when faced with highly specialized industry data. To demonstrate the nature of our interaction with ChatGPT, let's consider the following picture from our notes. This script was one of our initial attempts to create an IFC file from a simple text description provided by us. The initial outputs were unsatisfactory, often failing to generate viable IFC code or missing crucial elements like correct entity types or relationships. Over time and after numerous interactions, ChatGPT began to produce more accurate interpretations and responses, though it remained imperfect. It could identify specific columns and provide some details on dimensions, but the depth of analysis was limited to the quality of the input provided. This phase of our research highlighted the potential and limits of using a general AI model like ChatGPT for specialized tasks without extensive customization. Looking ahead, successful integration of AI could revolutionize BIM access, allowing a broader range of professionals and stakeholders to engage with essential data without specialized training. We believe this research may lay the groundwork for future innovations in the automated construction process. Thank you for your attention. For more detailed insights and a full account of our methodology and results, we happily invite you to read our paper.
And thank you. Let's proceed to the next presentation.
contribution to ICC AUA Turkey 2024. The topic possibilities and limits of AI-supported design and manufacturing processes in architecture. The leading persons behind this work are Professor Dr. Grunwald, Professor for Construction and Building Management at the Department of Architecture at the Alanya University of Applied Science in Oldenburg, as well as two of our students, Yara Hirsekon and Nick Anse, and myself, Yoshiko Saki. First, we introduce our research project in which we have dealt with parametric design and AR manufacturing technologies, among other things. In this process, we came across our initial problem, which prompted us to research this topic. This was followed by a study on the usability of different AI models for our approach. A case study was conducted and AI with the highest usability, and we were able to develop a working method with consistent results. Finally, we showed the results and an outlook. In the research project Aufladen, which is funded by the Stiftung Innovation in der Hochschullehre, we are developing a digital teaching portal together with around 20 students. Aufladen is the knowledge filling station where students have the opportunity to test and expand their knowledge in the context of digital transformation with so-called knowledge nuggets through practical, playful application in the form of learning videos, tasks, click tutorials, and quizzes. The research project offers space for various labs in which teachers can explore topics together with students through research-based learning and teaching. Aufladen offers labs on topics such as AI and the design process, parametric design, and AR technology. The lab areas of parametric design and AR technology are important for us today. Based on our research project, we have been able to create a course program where students have the opportunity to investigate building in combination with augmented reality and feasibility behind it. Before the construction process, the object in question must be designed and modeled. The designs were parametric structures. In the parametric design lab, it turned out that we were able to achieve the greatest learning success through prepared click tutorials. Nevertheless, a major problem emerged. The operation of the software is so complicated for beginners that they are severely restricted and cannot implement their ideas in the software. To create the designs geometrically, we use Rhino in conjunction with Grasshopper to then transfer the geometry to the AR glasses via the hologram software. Grasshopper is a visual programming interface and offers great possibilities for complex designs, but is associated with a steep learning curve. Students from our departments generally have no programming experience and often have no points of contact and therefore little understanding of programming. Here we see a project from the last semester that we designed, planned and built together with students. The bench is not overly complicated, but the code behind is. This entire script is necessary for this rather simple bench. We cover different areas such as the design process, the manufacturing process and the assembly process. Due to the complexity of the software, we came up with the idea of whether we could let the AI take the methodical knowledge about the software and include this step in our working process. Now we had to find a suitable AI for our approach. The main consideration was the workflow that the AI must be able to handle. Grasshopper offers the option of generating geometry via Python code. For us, this means that the AI must be able to translate our prompts into Python code. We can then easily read the output code into Grasshopper and check its function. If the code is faulty or does not achieve the desired result, we can return the error message to the AI and it can improve the code based on this. We can repeat this iterative process until the desired result is achieved.
We've developed an evaluation matrix to evaluate the various AI models. The requirements are divided into the following points. We mentioned the three most important. Is the AI accessible in Germany? Can the AI understand and generate Python code? And can the AI use images to create shapes in Rhino with Python code? We tested ChatGPT 3.5, ChatGPT 4, the Edge Copilot, as well as Gemini and Claude 3. ChatGPT 4 proved to be the most useful for application. The AI is slightly more powerful than the Edge Copilot and is not limited to 30 queries, allowing for the development of much more complex shapes over the course of a conversation. With unrestricted availability in Germany and the ability to understand and generate Python code, ChatGPT 4 proved to be the most useful for application. Additionally, it can use Grasshopper Python code to create geometric shapes and describe complex geometric forms. Having selected a suitable AI, we proceeded with a case study. Methodically, we chose an iterative testing approach. The process begins with a simple shape, gradually increasing the complexity of the geometry. The AI generates a corresponding program code, which is integrated into the visual programming environment Grasshopper to create the desired structure in Rhino. The goal is to create the geometry exclusively through code lines generated by textual input. First, we had to understand how ChatGPT interprets 3D objects and how best to interact with the software, which we learned through initial failures. The first successful result was a cube. To generate this, we instructed ChatGPT to create a 1 by 1 by 1 meter cube in Rhino using Python. Next, we tried more complex structures like walls. Here's one result. After the wall, we developed a request to arrange multiple objects in a ring shape, generate random heights, and explore what is possible and what is not. A failure in generating more complex geometry with ChatGPT 4 occurred when it didn't quite understand how to build a vase. We then learned from your failures how to better define shapes. After further discussions with ChatGPT, we could convey our idea of a vase, resulting in a better and more promising outcome in which we could build. We then tried to generate a vase without a prior discussion. Without clear dimensions, this attempt was unsuccessful. In the process, we developed a method that ensures the AI produces consistent and reproducible results. We developed this method after failing to create a vase, opting for a simpler approach, the block structure. Each of the two adjacent axes consists of a block, making it easier for the eye to recognize and for ChatGPT's image recognition to identify. The method uses the 2x approach to eventually enable a reconstruction. The image shows a 2D view of a vase, and ChatGPT should generate the Python code based on the overall height, block dimensions, and respective width of the levels.
This video shows the process of generating with ChatGPT 4. First, we provide the AI with a description of the vase with the appropriate dimension. It then generates the corresponding code. Due to the complexity of the research, it needs to refine and ensure output is defined as A, which is standard naming in the GH Python scripting module in Grasshopper. Then Grasshopper is opened and the GH Python script module is inserted to input and test the code, with the results displayed in Rhino. Next, the Z variable is added as an input in the module. The N3 sliders are connected to the three variables X, Y, and Z. The AI is instructed to adjust the code so the input variables can be modified via the sliders. Again, the output needs to be redefined as A. Now the new input the code in the Python module. The sliders can now be adjusted as the base shown in the video. ChatGPT provides information during the code generation process, including the libraries used, the function generated, and how to handle the code in Rhino and Grasshopper. The results of the videos can be seen here. As input, we constructed the AI to write Python code for Rhino and Grasshopper to create a vase providing the correct dimension for the vase. In conclusion, we provide an outlook on the future steps. Next, we will be presenting the research results on AI in design and manufacturing progress in the architecture at the University Future Festival 2024. There will be a digital collection of resources for our visitors to experience. Building on this article, we will next attempt to incorporate AI supporting not only the implementation, but also in the preliminary design process and the concept development. This would allow the technology to support everything process stage. Thank you for your attention and enjoy the rest of the presentation.
Thank you very much. Let's move to the last presentation of this session. Digital transformation, elevating landscape architecture through building information modeling.
National Conference of. Good day, everyone. My name is Meldi Ekasaputra. Today, I will present my paper in the 7th International Conference of Contemporary Affairs in Architecture and Urbanism. The paper title is The Digital Transformation, Elevating Landscape Architecture Through Building Information Modeling, or BIM. As we know, and according to the Wang in 2021, building information modeling is a digital technology that has emerged and continues to develop. And this software bringing significant change to the built environment because this software can improving the efficiency and overall design outcomes in the built environment. However, in the implementation of the landscape architecture, the software is the few implemented, and sometimes it is avoided because it is more related to the building architecture and engineering solution. Moreover, building information modeling is not comprehensive across all aspects of landscape scaling modeling, where the model may be used for prediction and scenario testing. It is according to the Larson on 2016. So based on the background as mentioned before, so the objective of this paper is to explore the benefit of BIM application in the landscape architecture design. And furthermore, hopefully when the landscape architect they use BIM can generate the sustainable of the landscape architecture design. The methodology used in this paper is basically involve a systematic literature review on BIM landscape architecture because this is to explore the purpose and benefit of BIM landscape architecture. The following constraint of the basis of the literature selection criteria. Number one, it is the paper or the research must be on the BIM in the landscape architecture. And number two is the paper we published in the last 10 years. So according to the systematic literature review, there are several theories that can be used to find the connection or the relationship between the BIM and the landscape architecture. According to the Abdirat and Lin in 2015, building information modeling as one of the innovation application or software is quickly becoming a pivotal approach to virtually integrating the required information for facility design, construction, and management. So according to this one, most of the project regarding the facility design, construction, and management, they use building information modeling software. The second thing, according to the Fritsch in 2019, reported that BIM could represent a concept for the information needed referring to landscape elements like a terrain model, retaining walls, and ways through exchange formation industry foundation classes. So there can make like a modeling in the modeling of the landscape architecture using the BIM. And the third is this technology allows landscape architects to create a digital representation of their design, facilitating the exchange and interoperability of information according to the Wang 2021. Here, one of the example of the benefit of BIM in the landscape architecture design project, where besides only to create a model of the landscape architecture, in the BIM also the landscape architects or the student of landscape architect can do the solar study. So we can see in this image, in the BIM, we can do the setting of the time to find out or to study the movement of the shadow in one area of the public landscape or in the landscape design. So the time for the solar study, we can set up according every 1 hour or every 15 minutes or every 30 minutes. So in here, in this image, this is the setting of the time is every 1 hour. So we can see the brightness of the design of the landscape of the public part start from the 7 a.m. until the 4 p.m. So this is will be give the benefit for the landscape architects to identify where is it the potential object or the landscape component can generate or can create a lot of shading area or the shadow area, and this will be can be identified where they can place the sitting area, for example, or maybe can place the shelter for the people when they visit this park. So in the current software, BIM or building information modeling, there are some benefits of the purpose of the BIM, or we can utilize BIM in the landscape architecture design. Number one, BIM as a media or a medium or as a software where our architect landscape can exchange knowledge or information with another discipline in the landscape design project, such as engineer, such as architects, such as maybe the plumbing engineer for the irrigation. Number two, BIM also can help the landscape architects in the pre-design stage where they can use BIM as for the modeling. And also BIM can help to generate the level of detailing of softscape landscape components such as trees. Number three, as I mentioned before, one of the implementation of the BIM is this a solar study. The solar study can inform the landscape architect about the study of the shadow, and then they can take the benefit from the shadow movement where they can place the sitting area or where they can generate more shading or more can add more landscape component to generate more shading into the landscape design. Number four, of course, when we make the modeling in the BIM, also we can generate the library of the landscape component inside the BIM. And also this landscape, this library, we can make the level of detailing. This can be only as a meshing, or can be a little bit detail, or can be more detail, or even can be more detail when they do the rendering of this modeling. And number five, of course, same as the other implementation of BIM in the architecture project or in the other construction project or engineering project. So this will be give benefit in the project management in the landscape architecture project. Finally, based on the explanation, the short explanation before, that we can conclude that BIM application has contributed valuable benefit to the landscape architecture design process. This can be start from the pre-design stage until the final design stage through the digital modeling of the landscape design. The study provides a solution software application and tool to generate a sustainable landscape design from the pre-design state of landscape architecture project. However, there are some obstacles still facing until now when we use the BIM. Number one, of course, there is a cost of the software. Maybe for some people or some company, they feel this software is expensive. And number two is about the human skill, how expert the operator of the BIM can operate BIM. And this is one of the investment as well that have to take consideration for the company who want to use the BIM. So they not only invest in the software, but also they will invest in the human capital. Thank you very much. That's all information about my paper.
And thank you. And this was the last presentation of this session. And now we can proceed with the questions. As far as I see, Professor Muarshi is here. But I'm not sure if any other presenters is here right now. If they are, please, you can introduce yourself. Hello. Is there any questions for Professor Muarshi among the listeners? First, I will give the word to you. Okay.
Hello, good evening.
Hello.
Can you hear me?
Yeah.
Hello.
Mohammed
Yes, Mohammed
Baybar.
Baybar. Yes, good evening, everyone.
Good evening. And were you one of the presenters?
No, I'm a lecturer in GAU University. I'm just
Okay.
interested with this.
So you have
Thank you.
probably
Yeah.
a
A question.
question.
Yes,
Okay.
exactly.
Okay,
So,
thank you.
Mr. Marshi, which is MT Pro.
Yep.
Yes, and
Yes.
especially for you and for everyone, thank you so much for this valuable presentations. Really, information was really well delivered. But my humble question, just very basic. In your presentation, you were speaking about enhancing their design abilities about the students using the AI. And then
Okay, yes.
I was just wondering about some questions, and you already answered them in the other slides, which is the design process slide. I think you speak about the contextual understandings and the creativity, that slide. But I'm just missing the connection between these two topics, like how enhancing the design abilities, and we already know the design process is very wide, broad process. So that's only my question. And again, thanks for everyone.
Yeah. Okay. So the major point over here is not this particular platform of the research. My research is not just only on the base of the purely enhancing by the medium of the tools and techniques, I mean by the AI, but also in terms of how on what grade we should integrate the AI as a part of the first base education, and then is the practice. So through that, creating that particular specific balance without compromising the architectural ethics, that is the major concern. On that base, I try to, let's say, create a particular narration on what ground we should, let's say, implement this thing. Obviously, into the practice, but before, ideally, it should be there and the education for that as far as possible. That's what my major concern is for the research.
Thank you so much. Thank you so much.
Thank you.
Is there any question among the listeners? And I have also a question, and Professor Mahshi, in my notes, you told us about the capabilities and the effects of AI, and also their positive and negative aspects of AI for an architectural design process. And you also mentioned a word which is very important from my point of view. You said placemaking. And so you asked the question, how can an AI tool be a placemaker like an architect? So I would like to ask, what's the most important feature of an architect which makes he or she as a placemaker so AI can be challenged?
Okay, I mean, let's say there are two separate concerns in this particular question. First of all, definitely in terms of, let's say, a placemaking based concept, let's say in terms of making any particular proximity or supposition in terms of placemaking, then definitely we have to think of all the concerns, not from the building or proximity point of view, but on, let's say, all the parameters. Let's say if you talk about the society, if you talk about the context, if you talk about the obviously the geographical conditions, everywhere we are supposed to think, and on that base we are supposed to create a proper sustainable based solution or situation for the concerned proximity, right? And let's say as far as I say that if we try to integrate the AI in this particular parameter, definitely the possibilities are there, but for that definitely we have to delve multiple layers in terms of let's say the way I explained in my let's say I think third or fourth that particular features of the AI, that is the GAM, right? So over there we can have multiple layers of the let's say data centric based concern. Over there we can easily introduce or let's say insert multiple layers of this particular placement, making these concerns of what particular specific let's say way of the proximity that we are creating. But obviously, as I said earlier, definitely it will come from the back of the experience and back of the creative mind as far as possible. That's what not really say about the architecture ethics. That's what the major concern is.
Thank you. So you think that it's the intuitive information that we process, it's hard to transform that information into a data. So maybe it's still hard maybe for the AIs to understand the aspects of these aspects, intuitive aspects maybe, as far as I understood.
Obviously. I think so. Because see, obviously the capabilities are there, but again, if we say what is the difference between the software and the human as far as the architecture is concerned, so definitely it will remain the same.
Thank you. Thank you. I also have questions for other presenters, but as far as I checked again, they are not in the session right now. Leo and or Yoshio, Leon, and Eka were presented, but they're not here. Yes. Okay, then this is the end of this session, I think. Thank you for the strong presentations, for very good presentations. I thank two presenters. And do you have any other contributions to add, Professor Riam, Nadi?
Well, I don't have any question. I just want to add that the presentations were really organized, valuable, and to the point. And they were very helpful because I'm one of the doctors that I still didn't use AI in the design process with the students. So now I am encouraged.
Yes, of course.
I'm encouraged to take this step the next semester and try with the students how to take their first steps or the initial steps in their designs with the AI. I think it's very helpful because it's now a very hot topic in architecture.
Yes, exactly. Also, it's probably the future of the architecture or any other disciplines, probably.
Yes, sure. So we have to move forward in this direction.
Yes, apparently, yeah.
Yes,
as we understood from the presentations as well.
Yes, that's it.
Thank you. So thank you, everyone. So do I need to do anything? I think you will stop the recording.
Okay, I will stop it now. And thank you for everyone. And Dr. Fonda for moderating this session. Thank you, everyone. Thank you. Okay.
So bye. I will end the session. Thank you.
Okay.
Bye-bye.
Bye.